and we're going to have an amazing time together today. Okay, if you believe that, say WorkerConf. That's right. I like this energy. Fantastic. We have some amazing speakers, some amazing events, and some releases, and all kinds of things. So it's very exciting. Before we do that, I need to give you one secret to having a series of good talks. Okay, because a lot of people think, hey, the talks depend on the speaker, and if the speaker is no good, then that's not a good talk. This is not true. I think every speaker is excellent, and your organizers have done a great job. By the way, give it up for the organizers. Yeah. 1, 2, there's a few around. If you see an organizer, what do you say to them? That's right. Thank you, and I'm sorry, maybe. Yeah, so I trust the organizers have chosen great speakers. We have Johannes here, who I'm going to introduce in a minute. So it's not an issue with the speakers. Look, this is the secret to having really good talks and learning a lot from them. You, okay? If a talk is good or a talk is bad is really, you have so much power here. So to start the conference, I want to give you some tips to making sure that the speakers do a great job. It's actually just one tip, and that tip is to approve of them immediately. They don't need to prove their resume. They don't need to tell you, hey, I founded Prisma, so I'm a big deal. No. You applaud them, you celebrate them because they're on stage. You know why? It takes a lot to come on stage and do a talk for a crowd who can be demanding and who can be maybe a bit reserved. Okay, sometimes we feel like we have to prove ourselves, and if you validate them from the beginning, so like he just walks on stage and you're like, awesome! Then he's going to not feel the need to win your approval, and he can actually focus on giving an amazing talk, and therefore the quality will be amazing. Does that make sense? Is that good? Yeah. Let's do a trial run. Let's pretend he just walked on stage. See? How does that feel for you?
Pretty good.
See, it's validated. That's good. Good job, audience. 10 out of 10. Let's begin the conference. We're going to have an amazing time. It is my honor and privilege to introduce to you my good friend and amazing speaker. He founded a company called GraphCool that does what my company does, but like 5 years ago. And he also founded Prisma. How many of you use Prisma here or have heard of Prisma? Yeah, look, everyone. Look at his face. He's like, wow, I'm a big deal.
That's not what I'm thinking. But.
He's a better man than I am. I would be thinking that. No, but founder Prisma today, his talk, I got a spoiler. I watched this talk last night. It is a treat. He's going to talk to you about the future of building applications. And it's insightful. It's technical. There's a nice thought experiment. It is a treat. So without further ado, my friends, give it up. Johannes Schickling!
Thanks a lot, Tejas, for this amazing intro. Feel very humbled to hear these kind of words from you. So maybe we can switch over to my slides.
Oh, keep my name up there.
All right. There we go. So today I want to talk about what I think could become like a new era of web development and app development. That's quite a mouthful, and I wasn't quite sure whether I should go with this talk title or not, but then I couldn't think of a better one, so I chose this regardless. But before going into my talk, I also want to thank thank the organizers, and I think we should all give them a huge round of applause. I've been organizing conferences myself, and it's like everything you got into it, and you practically don't get anything out of it. Like, it's not that organizers of conferences like get rich on a conference. It's really like they're doing it for you and for us, that we have a good time, and it's a huge amount of work. And so I'm really grateful that this conference is happening, that I get to speak here, and that we get to hang out in such an amazing location. I'm actually I grew up not too far from here, somewhere in Bavaria, and it just, can't say that too loudly in Berlin anyway. I'm Johannes. I'm living in Berlin usually. You might know me from Prisma, where we build database tooling, but around about 1.5 years ago, I had the chance to take a bit of a step back, do a sabbatical, and reflect, what do I want to do for the next 5 years? And so in that time period, I've done a whole bunch of like research on things I wanted to explore for a long while, and started working on a few different projects with different people. And yeah, one of these projects I want to talk more about today, and it's related to one of my interests, which is music, but more about that in a second. So over the last 10 years, I've spent a lot of time building and thinking about building different kinds of applications. And usually, I grew up with like the LAMP stack, and the LAMP stack was already like living in the cloud. And so I've spent most of my time thinking about how to build web apps. And we put these web apps in the cloud, and that can be like a simple Rails app, a simple other stack, or it could be like a very complicated microservice architecture. But I've always found it tricky to work with databases for building these APIs. That's why I started Prisma. But over the last 2 years, I started thinking, hey, do we really build like every app like in this sort of CRUD way? Does every app have to go into the cloud? And so I started exploring new ways to build software. So in the first part of this talk, I want to give a brief motivation of like why I even started thinking this way, and what I found. And also then the second part, I want to show you a concrete example of a project I'm working on where I'm proving or hoping to prove some of my claims here. So maybe we can start with asking a few questions. And I ask myself, whenever I run into a cave in a way that I like, I'm asking myself like, hey, why are we building software this way? So if I were to ask you, well, jank, what does that mean?
It means when things don't work smoothly.
All right, yeah, that sounds like most apps. Okay, so I encountered a few different questions. So for example, when I'm taking a photo on my phone and I want to share it with my friend, or I want to put it on my computer, why does it have to go through the cloud? And a lot you refer to with Shank gotten slower, somehow put into all of these apps, and the apps hold this data hostage. Why can't I access this data? Qualities of software that we want, and from a user perspective. So I think we can all agree on that software should correct like the way how it's supposed to be, without as few bugs as possible. It should just work, become portable. Like I'm using my iPad here to give this presentation, as well as my computer. It's like very portable, very nice. But there's some other aspects of cloud software, like fast, responsive apps. And there's a few apps that I think do a really great job at this. So for example, I'm using an email client called Superhuman, and I'm using it because it has Vim bindings, but it's also because it's really fast. And I really like this. And this is kind of like the main selling point, is like a fast email client that works everywhere, etc. So I really like this. However, most apps that I'm using, Oh no, this is actually loading our spinner, yeah. But like most apps behave this way, so that we just like loading stays everywhere, slow apps, etc. And that's quite frustrating to me. I mentioned yesterday I came by train, and I was hoping to like get a lot of work done. Kind of did, but a lot of apps really like weren't helpful in like the poor connectivity or no connectivity mode. And yeah, I think it was actually better at some point where I've been using Dropbox a lot and not quite like use all the cloud apps, where I can work offline. When I have connectivity, everything syncs. That was quite nice. But I now like love Notion, but if I don't have connectivity, I'm looking at this message a lot, and it's basically useless. I guess we all, I'm not sure whether we like seeing this or we hate seeing it. Maybe we can go home early, but it certainly blocks us from doing our work. So whenever Slack, GitHub, whatever is going down, it's kind of, yeah, we're blocked. So that's not great. Another aspect is longevity. So I have a ton of apps that I've been using in the past can't access anymore. But it doesn't have to be this way. Like, this is just about like when I touched my first computer with MS-DOS. And turns out these software tools, like MS-DOS apps, they still work. Like, you can still open these tools, etc. They still work. Unlike a lot of apps built by Google. Not sure whether anyone liked using Inbox by Google. I did. It's gone. Sad. Killed by Google. Tons of different apps. It's not great. I want our apps to last. Yeah. And then another aspect, I think, which luckily gets more important over the last few years, especially here in Europe, is that apps should be secure and private. And there are some great examples that can lead the way here. So I'm thinking of Signal, which I think is doing an amazing job of like keeping our data secure and private and valuing this. At the same time, like having a pretty good user experience. Whereas a lot of other cloud apps allow for this. I'm not sure. Have you been pwned? Yeah? You should go to the website. I think everyone should raise their hand. Pretty sure. This is a website that tells you whether any of your account got leaked, etc. And like, yeah, use a password manager. Anyway, I think every app should be secure and private if it has my data. Another aspect that's really important to me is user agency. So what I mean with this is that we use apps to do certain things, and not everyone has the same workflow, and the apps should be flexible enough and give me enough control that I can do what I want to do. So I think Notion here does a great job, for example, through the database feature, that you can just model it in a very flexible way to support you in your workflow. Quite different to most apps. For example, my bank client doesn't even allow me to search. We can no longer build apps that give us access to this data. And last but not least, I really like that we collaborative software. I think this is a big benefit we got from the cloud. Like, we didn't have this with MS-DOS. We couldn't really collaborate, maybe with like a disk that we would exchange, but most cloud softwares is really nice. So, for example, I was just sharing a password with a friend, or was just sharing a password with my own device. So that's really nice. So it is like collaboration in a very useful way. Also, Figma, I think, has done an amazing job of like building collaborative software where we collaborate in real time. Where collaboration then starts to break down is if it's not fully thought through. I'm not sure whether you ever had like a merge conflict in using any iCloud tool, for example, text edit here, when you've used it on 2 devices, and there's no way going back. The other document is just gone. That's not how collaboration is supposed to do. Anyway, so I want all of these ideals in my software, and I think that's why we're here, right? So we want to build great software. But building great software in like today's cloud-centric approach is really hard. And yeah, I've spent a good amount of time like fiddling with these sort of tools. Like, are you familiar with like CNCF Cloud Native Foundation landscape here? Yeah, there's like, if you don't raise your hand, good on you. But there's like a lot of complexity that really takes to like even operate these cloud apps. But yeah, I want to like work on my app and not like know how to put together these like, I don't know how many, like looks like thousands of tools that's necessary to fulfill all aspects of a cloud app. So I was wondering, hey, is there a better way? And I kind of like started talking to a few different people, and that led me to discover like a new approach to think about software. So I'm going to start with a thought experiment. So in today's era with cloud-centric software, our data lives in the cloud. Typically, here's like simplified in one database, etc. But our data lives in the cloud. But what if our data would primarily live on our devices, and we would use the cloud to facilitate that we can still collaborate, etc. That's pretty much like how Signal works already. Like, our data doesn't live in the cloud. Our data lives on our devices, and we can still like move on like we were using WhatsApp. So I'm claiming that we can, with this simple change in our architecture, we can get all of these ideals. We can get responsive data, we can get responsive apps, highly available apps, apps that last, apps that are secure and private, apps that give us agency, and hopefully then we can still make them collaborative. So this idea has a name, and it's called local first. Local first was first described by a group of folks at Ink and Switch. It's by some of the founders of Heroku and really, really great people, and I can highly recommend you checking out the article if that sparks your interest. And other people are also starting to pick up on this. So here's like Alex, the founder of Clearbit, has tweeted about this the other week, where he sees that cloud-first software might be the next big wave in web development, and I agree. That's my talk here. So what is local-first software? So it's really like it's quite a simple idea. So moving the data into the client so that local-first software runs on the user's device and can collaborate with other devices, other users. It's really as simple as this. Sounds quite abstract, but it's a really simple idea with a bunch of like technical implications that we now have to pull apart. So let's look at a simple tech architecture. Maybe before going into this, my first line here is like PWA. Raise your hand if you've used a PWA already. Okay, that's a lot. So please keep your hand up. And now keep your hand up if you've used a PWA that actually fully works offline and you can do what you wanted to do with that PWA. Okay, interesting. I'm interested in the two of you, which apps that have been. Okay. Okay, that sounds like a great example, yeah? Okay. Well, that's quite visionary right there. Since like I'm thinking when I'm hearing PWA, etc., I'm like thinking of like the Twitter web app, which is cool. Like gives us like the skeleton app, maybe with like our profile picture, but nothing more than that really. And I think it takes an approach like local first to make PWAs that work offline truly happen. And so I think we have the technical foundation, now we just got to do the work. And so yeah, a good architecture for a local first web app would be to like follow the ideas of a PWA. By the way, it's not just that we're I think primarily web developers, but local first spans way more than that. Like actually, it's like most local first software right now like happens to be on mobile development. Games, but like I'll get into that in a second. But from a tech architecture perspective, I think the primary thing we need to rethink a bit is like the data management. Again, like we're moving the data primarily out of the cloud into our local devices. So we got to figure out like what is a database that we have locally on our machines. Since like our phones, our laptops, and tablets, they're like very, very capable. They have like so much storage, so they can do all of this. Now we just gotta like teach them how. Also, we gotta, beyond like the database, we gotta figure out like how to store actually files, how to persist things. And for the collaboration aspect, we need to figure out how to sync things. And yeah, this takes quite a bit of work, but I think we'll get there over time. But what's the most interesting thing to me is like it's really liberating to have the server be optional. There is no server needed. Like Signal works by like just devices communicating. In the cloud, sure, there's maybe like some servers, but they're just helping to coordinate. They're like if they're down, it still works. And yeah, the cloud here, the role of the cloud is changing. It's like rather facilitating, it's participating, it's helping to sync, it's helping to back things up, but it's no longer the only thing that makes everything work. So I want to put this into perspective with like two other technologies you might have heard of. So one is like offline first, PWAs, just talked a little bit about it. and I think here the main point of offline first, we never really got there, that the apps truly work offline, because I think most offline first apps have been really making offline, unlike the name suggests, a bit of an afterthought. It was always like a caching strategy. How can we still keep the data locally? But I think it never quite works if you don't make that the starting point. And the other thing I want to put it in relation to something I know very, very little about. So maybe you know more about it, and like you can tell me that this doesn't make sense. But my perspective is that the shared aspect between like the Web3 movement and local first is that we both want to go to like a more decentralized architecture. I think, from my understanding, Web3 is much more about like the protocols, about incentives, governance, etc. And local first is much more about the technical architecture, like where does data live, etc. And like maybe these approaches like meet sometime. But yeah. So I'm not claiming that all apps that we're using today would be a great fit for local first software. But I think a subsection of these are a great fit. So for example, what I might summarize is like personal tools, like tools that we want to actually do our work with. So these tools are typically things where we put in most of our data, we can have access to this data, we can, and like the email client is a good example. I have access to all of my email, music apps, personal note-taking software, maybe like Notion, for example. All of this would be a really great fit to be built local first. Whereas what I think doesn't really make sense to attempt to do in a local first way are more centralized platforms. Like if you have a bank, like as a user, I'm not an authority to tell the bank like, hey, about like transactions, etc. Like I really have to participate in that larger system. Or if you have complex HR apps with like a lot of policies, etc., I should not have access to all of this data. It should be governed more by like a central thing. So that's less of a good fit. But I want to concentrate a bit more on like these personal tools, since this is what I'm using most days and what I'm frustrated by when they don't follow these ideals that I've described. So there is a surprising amount of local first apps already out there, and a lot of apps that you have on your phone are already following this idea of local first. Like a lot of iOS core apps, like Notes, etc., is already working in this way. And a lot of video games as well are also local first. They work fully offline and then have sort of like a online mode that hooks into it. Dropbox facilitates a lot of like local first workflows. Calendars, to-do apps are typically built this way. And pretty much all of our like IDEs are also local first. I want to give a shout out to a few apps that like are a bit newer that are following this trend. Like Muse is one of the projects by some of the founders of Heroku, who are like behind the movement of local first. An amazing app that's built on this principle. Actual Budget is I think by James Long, a budgeting app. It's recently made open source, so if you're looking for like a reference implementation of local first, recommend you checking this out. And Linear and Superhuman, I think, are really beloved apps, and I think what makes them so great is that they follow this approach of local first. So before moving on to my concrete example, I just want to talk about like a few of the challenges that we're facing. Fortunately, I don't have like a great answer for you. It's like probably read the essay and then see how you would like pioneer your way towards that as well. But I think there will probably be like a Ruby on Rails over time, but right now there isn't. So you got to think about like local like state management, like how to persist files, how to sync your data. And for syncing, there's a great technology already emerging over quite a couple of years called CRDTs. That's like how Google Docs, how Figma, etc., like does the collaboration. So there's already quite a lot of great technology there, but it's still a new way of thinking of like putting them to work. And like you've seen with this iCloud merge UI, you still got to think about like am I building a music app? Want to give you a brief motivation? Want to give you a quick demo instead of product demo? Should really say like prototype demo, but you'll see it. And then I want to show you like a couple of like cool aspects of like how this app is built in this local first way. So why am I building a music app? I like listening to music, a lot of music, in a lot of different places. So I listen to music on like SoundCloud, listen to music on BBC, Radio 1, YouTube, Spotify, Bandcamp, my local library, and I always find myself like having a ton of like tabs open in my browser, mixed between all of these like Stack Overflow questions. And so I like similar to how I'm like using a mail client, where in one mail client I have like all of my email providers and email accounts. I want to have like one music app where I have like all of my music. So that's one motivation. But the other one is, even if I was just to use Spotify or just to use Apple Music, I'm claiming that these music apps that we're using these days are actually not that great. So Nat's been calling out Apple Music in this regard, that he gets frustrated with like the multi-second interactions. I'm mostly using Spotify myself, but it's kind of the same there. So here you see, like whenever you're selecting a playlist, just like look for all of like the waterfall of like loading state. It's like still fairly fast, but why do we have all of this loading state? Doesn't make any sense. So and to contrast this with our prototype that we've built, like here, every click, next frame, instantly you're gonna see your playlist. Like this is the sort of speed that I want to see. And so yeah, just quickly going through Spotify. Love Spotify, by the way, but like still, I think hopefully they'll get there. But I want the app to be more responsive, and right now it feels pretty slow and laggy. I want my music to be always available. Like back in the days, like when we had an iPod, the promise was like your music collection always in your pocket, and your pocket, like whether you're on a mountaintop or whatever, like didn't care about the cloud. It was always there. Now it's like not so much anymore. Longevity, I'm very concerned about this. Because Spotify actually keeps like revoking access for me to some tracks. Like some of my playlists look like a Swiss cheese because I just can't access these tracks anymore. And like, what if like Spotify shuts down some point? Like this is like important part of my life would just be gone. So I'm very concerned about this. Secure and private. Like Spotify weighs way too much about me. I'm just listening to music, but like they're really like analyzing all of my data, and like I don't like that too much about that either. User agency, I want to do way more with my music data. As mentioned, like for DJing, I really need to like annotate my tracks, like keep genres around, leave comments, and with Spotify, I can't really do that, and I can't do it with any other app really either. And collaborative, sure, Spotify has a few collaboration features, but I would like to see much more in that. So for all of these, rant over about like music apps, but this has led me to build my own music app. It's called Overtone. At least this is what will be called eventually. There is already a website where in the future you can sign up to a waiting list. But Overtone is meant to be a local-first music app. So a music app that follows these ideals as mentioned before. Right now works on desktop and works on web. In the future, hopefully also on mobile. I'm working on this with two friends who currently do a PhD at MIT, who are working on some of the underlying tech, and this is a great collaboration. So, so here is the music app. This is the desktop version. I hope you all can see it. And so this I have here connected to here. And that has then basically pulled in my entire music library. So you see here, like today is Friday. Friday means release radar. I haven't listened to these tracks yet, but this is my today's release radar. with all of my tracks in here. I can go like through the various playlists, etc. And notice like that it's really like instant. Like it's always when I'm clicking on something, there's in the next frame it's already there. And I can play music, etc. And one aspect that I think is also really cool is that like if I'm going to this playlist, your top songs 2021, and I scroll down, notice I'm going somewhere else, and I come back to the other one, the scroll position is retained. And this works across like app restarts, etc. It's a really nice little touch. So basically the app state, no matter where you are, is automatically stored. If you were to try to do this with like a more conventional web development approach, it's kind of like ridiculous. Like that would be a lot of work you'd need to do for such a small thing. But in this architecture, you just get it for free. So it's like a lot of nice little qualities you get for free. So jumping back to the, there's also, by the way, a web version of this, which works just the same. So let's jump back into the demo here, into the slides. So what already works? It's not like what's missing, but what already works, because like the app is at the very beginning, but we have support for SoundCloud and Spotify where you can authenticate, import your own library, and play music. We don't yet support that you can search across the entire platform or that you just can sync back changes that you're making to the platform, but that's coming pretty soon. So we're all developers, so you're probably asking yourself, okay, what's the tech stack of this? So this is, I think, quite a nice collection of new technologies. Some of them we're going to hear actually like a full talk on today. So for example, we're going to hear a full talk on Tauri, which I've been using for the desktop app. That, for example, gives me, instead of like a full bloated like 200 megabyte Electron app, it actually gives me a 5 megabyte Mac app, which takes way less resources compared to Spotify, etc. So it's really pleasant to work with that. For all of like the web tooling management, I'm using Vite, which is an amazing tool that powers a lot of the aspects here. For the view layer of the app, I'm using React. And for the business logic, I'm using a library called Effect. I think we're also going to hear a great talk about this today. Technology I'm very excited about. Language-wise, it's like 80% written in TypeScript, all with modern ESM JavaScript. And 20% of it is in Rust. That is partially to interface with Tauri, which is the starting point is Rust, but also for a lot of WASM. So for example, the entire music streaming is implemented in Rust and WASM because it needs to be really fast and it needs to work cross-platform. And for encryption and compression, I've also started to use WASM. It's kind of like a nice little shift in my habits of like how I'm looking for reusable software. In the past, I would have like gone on NPM, looked for encryption, or go on NPM, look for compression. And nowadays, for these sort of like high performance things, I rather Google for the WASM version of something. Because that has worked super well. So I've like slowly but surely shifting some of my code reuse patterns to WASM and can highly recommend you do the same. Data management wise, that's what I want to talk a little bit more about. That's the interesting part. That's specifically local first, where we're building a little framework called Riffle that's based on SQLite. And of course, I'm also using GraphQL in my stack for the data access. For repo tooling, it's a monorepo using Yarn, and it uses Nix for all sorts of like native dependencies. And in terms of observability, just to know like, hey, which code is running, debugging, I'm using OpenTelemetry, which I can also highly recommend. So here is the architecture of the app. A quick check in the last few rows. Can you still read this? Otherwise, I zoom in. No chance? Okay, I'll zoom in. So here's the big picture. Music sources on the left, app on the right. I'm gonna walk you through now left to right. what's happening here. So we have the music sources, and the music sources, I have a component in my software called music source connectors. So per music source, Spotify, SoundCloud, I have a connector, and the purpose of this connector is that it that it extracts all of the data from this music source, all the user's data, and turns it into an event log. So for the overall data architecture, we're making use of a data management concept called event sourcing, and that allows us for like this unidirectional data flow. So the point of these music source connectors is to build the event logs. And the event logs are very accessible to the user, are actually stored in your user's file system, so you can access them, etc. And these event logs are then imported by the app. So they're listened for changes, are then imported into the app, and are hydrated into an in-memory SQLite database that's running in WASM. And this in-memory SQLite database is then used by the query engine of Riffle, and then exposed also via an optional GraphQL layer to the React view layer. And what's really, really nice about this is that the queries are automatically reactive. So if anything is changing, you don't need to manually take care of like listening to changes and like patching your state. All of your state automatically updates in real time when anything changes. That's an amazing property. So, and yeah, because we're building a music app, and music app is supposed to play music, we also have a sound engine that is mostly written in Rust and runs via WASM, streams using the stream APIs of the music providers, and plays it back on the user's device. So let's take a look at what Riffle is. So Riffle, as I've explained, like it implements the concept of like relational reactive queries. Relational because it's based on SQLite, so we can model our database based on the event log however we want in a very flexible way, and we have like the full range of abilities of SQL at our disposal. And this React library gives you hooks where you can write queries either using raw SQL or using GraphQL. And what's particularly exciting about this, besides that it's reactive, is also that it's fully synchronous. And you might be thinking, wait, synchronous, like that's, like we want to build async apps, right? Because it's faster. But actually here, given our data is local, and most queries take less than a millisecond to execute, we can actually do the full query of our apps and our views synchronously. That means like in the first React render, we don't need to have like a loading state and then do like a use effect and like query something, where you can like in the first render query our database and we get 60 FPS rendering. So that's really incredible. And yeah, what might be different to think about is like that it's kind of encouraged that most state lives in the database. I was kind of skeptical about this myself, but like step by step I've moved more state into it, and it's been really nice to work with. So here's a quick code snippet where on the left you see the side navigation of the app with like all the playlists, and the code for that in a simplified way is really like as simple as like using this use Riffle hook where we do a SQL query, select all from playlists, and that's it really. And like this updates if anything changes there. And as mentioned, I'm using GraphQL here. So it looks like this, that we have our GraphQL query where we just query for the playlist, name, track count, etc. And then that's it. So it's like from like how you read data, incredibly simple. And yeah, it's probably like a fifth of the code I would have that's needed compared to if I were to build this as like a web app with like a server and an API, etc. So really pleasant to work with. And yeah, speaking of benefits, I kind of get the best of both worlds. I can still use most of the technologies that I like and use of like a more like conventional cloud app, but I can really simplify the stack. I don't need a server. So it's like really serverless here. Also, the state management is really simplified because we don't need these async state patterns for views. And it's also quite nice once you thought through the data architecture, and this is domain specific, but here the event sourcing pattern makes a lot of sense. It's really nice to understand where changes are coming from, and the debugging experience is really amazing. So I mentioned I have like these database folders, these event log folders, and it's actually like you see it here. I have like different sort of backups of these database files, and this is because like I can simply, when I run into a problem, I just copy paste, make a backup of that database file, can share it with a coworker, and they can inspect it and like load it up in the same state, like the same scroll state, same form state, everything. And this way we can like have a reproduction right as a database file, which is amazing. And in terms of deployments, there aren't really stateful deployments where you need to do like database migrations or anything like that anymore. It's all stateless. Like if you do a deployment on Netlify or Vercel, like it's an immutable deploy. Basically the same thing here. However, it's also wasn't quite super easy to get here. Lots of pioneering work was needed to do this. It was surprisingly hard to synchronize the playback state from Spotify that also supports Sonos, etc. And unrelated to the local first aspect, it wasn't quite such a pleasure to work with the APIs of the music platforms. It's like, to be honest, it's like not quite in their best interest to expose all of their data. But yeah, it's like you deal with a lot of rate limits, etc. And yeah, implementing the music playback that it's fast and still works with their terms of service was quite tricky. And the next steps that I'm gonna work on here is like syncing and version compatibility between these apps. That's gonna be quite a bit of work. But yeah, I wanna briefly just now circle back to my initial claim about the app. Like, I think it's very responsive. I am excited as like available everywhere. Like I can demo this to you offline. Streaming music still requires internet, but like at least the metadata is there. And with other sources, you can also listen to music offline. Longevity, my database files, no one's gonna take them away from me. They're always there. Is completely secure and private. There's like no analytics. User agency, I am control of my music library again, which was one of the main premises of this. And collaboration hopefully will be implemented soon. So yeah, I want to leave you with like one last thought, which is a quote I really like. We shape our tools and in turn they shape us. And I think a lot of us and a lot of our apps have been shaped by the tools that were built over the last 10 years, which is everything, like moves everything into the cloud, locks everything into the cloud. And I'm very excited about like exploring how to build tools and how to build apps that are more embracing these ideals that I've talked about before. So yeah, that's what I want to leave you with today. Thank you so much for your attention. I think I went a little bit over time. Not sure whether we have time for questions. If not, feel free to just ask me afterwards. It's the first time me talking about this topic, so hopefully I could do it a little bit of justice and make you at least curious about this. So thank you very much.
There we go. Let's hear it for Johannes one more time, everybody. We are a little bit over time, but it's totally cool. I think we can take maybe 2 questions. Does anyone have questions? At least 2 questions. If you don't, I will ask you a question, and then you can continue thinking. But the second question has to come from you, okay? Question for you. Actually, it's a 2-part question. 1, what was the biggest challenge in doing this? And 2, do you intend to finish this project and like ship it?
What was the biggest challenge? It's basically like, where do you start? Like no one, to my knowledge, has like built a project in this way and like talked about it that I could just like reference it. So I'd really think about this from first principles And in the process, I basically rebuilt it 20 times, just because like 19 times before I got it wrong, and we'll probably rebuild it 20 times still. But that's also nice to me. Like, I want to build my software in a way where this is easy to do. And yeah, I do intend to build, like, for selfish reasons, really. I want to use this app myself. So I want to at least get it to that stage, and it seems like a lot more people are interested in it. So yeah, I want to explore what it looks like to put it out there.
Awesome, thank you. That's a great question. That's a great answer to my question. It was also a good question, right? There's a question over there.
Do you plan compatibility with Winamp skins?
So the question was compatibility with Winamp skins. I was a big Winamp user. I don't want to quite say challenge accepted, but I'm intrigued.
Awesome, yeah.
All right.
I heard Winamp is making a comeback soon.
I
I
think someone
They have a new
acquired the
website,
rights.
yeah. Yeah. Cool. All right, we'll do more questions after. Thank you once again, Johannes. Let's
Thank
hear
you
it
very
for.
much. Thank you.
I'm so moved by this whole topic, this whole movement of like local first and SQLite and all of it. I watched this talk last night. I got to see it again. Nice improvements, by the way. He took my feedback. This is cool. And wow, I feel amazing about it. We're gonna let the next speaker come up. Feel free to come up and set up your thing. I'll distract them while you set up your computer. Some housekeeping things. We do questions after. It probably took you by surprise. This is because I made a mistake, and I should have mentioned that get ready with your questions. So consider this the rectification, okay? Here's this thing. Do I look like I have a massive face tattoo right now? Because I saw a picture. I should maybe stand here. Okay, so questions. During the talk, I want to encourage you to spend as much time as you can paying attention to the speaker. But that can look different to different people, right? For some people, you actually like pay attention when you're looking at your phone. I do this. And people think I'm distracted, but I'm not. I'm listening passively. That's valid, but do pay attention. And I think probably the best way for you to get your questions in is to tweet with the hashtag WorkerConf. So anything you tweet hashtag WorkerConf with a question about the talk, we'll see it, I'll see it. I live on Twitter, in case you haven't noticed. I think we all do. Or many of us do. So I'll see your tweet hashtag WorkerConf with questions, and then I can ask your question for you in a microphone so that people hear, and then we can. Does that sound good? Yeah. Okay, awesome. He's still getting set up, but I wanted to do another thing and talk about demo gods, okay? Because everybody, we were talking earlier today with Daniel, and he mentioned he wanted to do a demo, but didn't feel like making a sacrifice this morning to the demo gods, okay? One quick note about that, not to like take away from people who actually believe in like a capital G God, but here's what I want to tell you. If we talk about demo gods, like lowercase g, people are leaving because I mentioned God. That's but if you want to talk about a lowercase g God, you are the demo gods. That's deep. But what I mean by that is when a demo happens, you decide how good it is or how bad it is. You know why? You can support your speaker. So if someone does a demo and it falls apart, give them the courage, support them, applaud, and the talk will get better. I guarantee it, okay? So just a reminder, you're in control. Your applause, your support, your reactions matter, okay? That is, you have so much power as an audience, and I just wanted to remind you of that. This next speaker, Mr. Daniel, co-founder of Towery Systems. You saw a little bit of Towery in Johannes' talk, is here to tell you today about the future of like multi-platform apps. I'm super excited about this as a person who has used Electron and wants something better. Can I say that? And so I'm really excited for this talk. It's kind of like you can build apps for anywhere. That for me is super exciting. I won't spoil too much of it. It is my honor and privilege to introduce you to Daniel, everybody. Let's give it up for Daniel.
How you doing, buddy? You guys can hear me, right? Cool, thanks. And thank you to the organizers. Welcome to WorkerConf. Thank you, Johannes. I don't see you, but we've been working on Towery for 3 years, and that was literally the first time at a conference where I saw somebody demo a Towery app, and it literally brought tears to my eyes because we've all been in this kind of COVID situation where, we've been limited by the distance of our screens. And I think that as workers, one of the most important things for us is to, broaden our horizons, to look really far. And in these online worlds of Zoom calls and Hangouts and, Stream Decks, you really are limited to just what you see in front of you. And I think that setting here in Dornbirn and around Lake Constance and these mountains is maybe an opportunity for us all to really reflect on the very far future and how we got to where we are today and what it is we want to build. And that's actually the inception story of Towery, because, 3 years ago, things were pretty much the same as they are today. You download your your tool chain and you set up you want to build an app like what Johannes is building. What do you have? You either build it with Electron or maybe you're using Qt, and the options just weren't there. And I think it has a lot to do with this paradigm of software as a service, infrastructure as a service. Amazon's, Microsoft's wanting to sell you more hardware, wanting to sell you more compute time so that you do everything in that ecosystem. And I'm sure you've all heard the horror stories of not putting limits on your AWS minutes and waking up to $20,000, $30,000, $40,000 invoices. And I think that born out of this free real estate mindset where, for the past 20 years, we were just happy it worked. Like, yes, it works. I can ship. And now we're getting to a place where, okay, we just got out of a 3-year COVID situation. Now we're in the brink of a new world war. The ecological situation is falling apart. And my brand new Mac, Book Pro, M1, whatever, struggles to run 4 apps. You look at your memory consumption, it's like, why am I using 10 gigabytes of swap? Oh, okay, yeah, I know who's to blame for this, and it's not Electron. Because I think that Atom and Electron were very important stepping stones in getting something to work, but now we need to work better. And I'm gonna kind of walk you through the story of Towery, and what was shocking to us was the resonance that we got right away. I mean, being Hacker Newsed is one thing, and dealing with the Reddit trolls is another thing, but also listening to the stories that people were telling about the things that they hated. And I mean, if you just look at what happened to 1Password when they released their Electron app, the shitstorm that happened just because people's computers were being used. I mean, that's why we use computers, and that's where this local first idea really was born. And people say, yeah, this is the Electron killer, but I think where we're going is more toward this mentality of building things properly, but doing it from a honorable, secure, and performant way that conserves resources, not only on your computer, but also for the environment. And we're going to talk a lot about those topics here. There's a really great project out there called OSS Insight. I highly recommend you check out your GitHub project or your favorite project. If you scroll down on the screen, you'll see the projects that are interested or stargazing on Towery. Almost 1% of them come from Alibaba. Why is this? Why is Tencent interested? Why is Microsoft interested? ByteDance. What do these people all have in common? They have massive cloud expenses. They need to start conserving resources because, if you talk to somebody that says, yeah, here, use my API, and they're like, okay, gosh, how much electricity is that going to cost? And they're like, well, here's the benchmarks. And they're like, okay, so what we're going to do is we're going to set up this service on a blade in Germany because that's where our ops guys live, but then we're going to ship it to Sweden because the electricity is less expensive, right? This is how modern corporations are thinking, and from the perspective of being a lighthouse, I think it's important for all of our projects to really recognize the importance, the utter necessity of listening to these alarms going off in our heads because the world is burning and we all have to do something about it. Now, Stargazing is great, being trending is awesome, being in the top 185 repositories on GitHub is great. I think the next one is going to be Git. We're going to have more stars than Git, and it's humbling to be, I think this is an old version of the slide now, we're the third most popular Rust project just after Rust. But what we discuss a lot in our team, which is about 18 people right now, is that the thing that we can do better as a large community is offer people tools that are safer. I'll just give you an example from a totally different ecosystem. So in one of my former careers, I was a carpenter. And there's a type of tool that's super dangerous in the wood shop. It's a circular saw. And the circular saw, if you're not paying attention, it can shoot back that piece of wood at you. It will cut off your thumb if you're not paying attention. And it actually happened to a professional modern saw. If it detects something conductive, like a piece of metal or a piece of skin, it shoots a piece of aluminum into the blade, stops the blade, you ruin the stopper, but you don't even get a cut on your finger. Responsibility. And with better DX, what we're experiencing in these communities is that people just take the tools that are given to them and they don't think about what it means. NPX create Towery app, and you've got a Svelte build app in 2 minutes. Maybe I'll show that demo if we have time and I don't talk too much. But who's thinking about the security? Like if you do the same thing with Electron app, you get these massive warnings in the console, gosh, you shouldn't be using the internet with this app because it's dangerous. and everyone is pointing fingers. And we decided, look, we're going to point the fingers at ourselves. We're going to help people build baseline apps that are more secure out of the box. This is a true. Someone on our on GitHub made a comment about, security shouldn't be wrong. Security always is a concern, especially once you start getting into desktop applications, into mobile applications, when your apps are outside of the sandbox of the browser. You're touching the user's system. You have access to their file system. Protect their identity. Have I been pawned, as Johannes shared earlier, is a real thing because security is always kind of the thing you bolt on at the end. And I can tell you, technical debt, architectural debt, is something that you almost don't address when you get to the end of the project because you're happy it just works. So in order to verify our assumptions that we're making a better system, we had a 6-month audit process with an organization called Radically Open Security. We published our audit report. It was both a horizontal and a vertical audit, which means they looked not only at the libraries that we've constructed, but also an application using all of the APIs and bells and whistles, including our updater, all of that stuff, in order to verify that we were right, and we weren't. There were about 40 or 50 findings. And a lot of advice. And I don't know if many of you spend time in the security industry either conducting audits or being on audit teams or reviewing the work of auditors. I have to recommend you choose projects that are concerned about this and read the audits. They're really exciting. And one of the things that we thought was a good idea comes back to JavaScript land. I'll talk a little bit more about the actual architecture of Towery in a minute, but basically, you have a core part of the application written in Rust. That's doing the inception of the application, rigs the windows, et cetera. And then you have your user interface. And there is a way for these two things to talk to each other. It's kind of like a bridge. And you're sending basically a structured message from one side to the other side. And we thought that, putting in a nonce might have been a good way to make it secure. Turns out it wasn't. And so what we ended up doing is we created a novel method by which the communication pathway to the secured APIs only can happen, if you choose this approach, to isolate the functional handles to the code that you expect. And this is something in JavaScript that's bugged us for a long time. We're happy to see projects like Solid.js and Svelte coming around that don't mess with the prototype anymore, which is obviously important. But the moment you ingest any kind of third-party code or even any kind of remote code, you are opening pathways for attackers to access your system, and that means basically you're allowing people to use APIs that they shouldn't be using. And we built a way that actually prevents that, kind of like how tree shaking out functions works. If you don't want to use a part of a library, you just ingest that one part and the rest is removed from your code base. Security is hard to get people to care about. I didn't hear anyone smiling or crying or laughing, but this should make you maybe grin and cry a little bit. Because, you know, Tauri apps can get really small. Like, if you try really hard, you can get them down to sub 500 kilobytes. And the way this works is, instead of a multi-purpose engine like V8, we are only shipping the actual code that you need to run your app. You know, we're not, if you don't need to use our fetch service from the Rust side, we don't ship it, right? And it's really possible to go very, very small. And there's good reasons to do that. Now, Johannes said before his app right now is at 5 megabytes. I'm not sure how much you know, extra compression he's done on that, but one of my friends used to work on a relatively popular application that streamed over BitTorrent into your computer. You could watch videos while you were streaming from BitTorrent. And they got super, super, super popular to the point where they had hundreds of thousands of users all around the world, and they were shipping updates 2 or 3 or 4 times a week. And it worked pretty well until you started realizing that their mirrors were going down because they hit their absolute traffic limits. And, you know, calculating the energetic cost of your application, your APIs, your data transit, it's important, but we thought we'd try to, you know, do some visualization here. Now, I don't know how many trees get cut down in this region every year. I'm guessing it's not 200,000, maybe not 2 million, but it's kind of obscene. You know, this free real estate idea of, well, I build it, I ship it, it works, we ship another update, we ship another 600 megabytes. We are ultimately all responsible for this environment that we live in, and when we don't do our part individually, then we can't point fingers at someone else for not doing their part. I think it's extraordinarily relevant, and I think that what you're seeing nowadays is that also consumers care because they have limited bandwidth on their devices, and it's really important. And you know, this kind of brings us back to the community, right? We built Tauri so that people can build better apps. But what we've recognized is that, and I'm sure you've seen this in some of your projects too, the community comes together and helps the community. And right now, like I said, we have about 16 people who've joined us, who've started providing improvements to Tauri, and they all kind of meet and hang out over at the Discord. I don't know how many there are. It's a couple thousand people. It's growing. And it got to a point at a certain point where we started getting contacted by venture capitalists who were like, woohoo, next big thing. We saw all of your trending stuff. Let's do some business. We got scared. I got scared. I've been working in open source, and I don't think I've sold out. But I was worried about creating a company and transferring the moral rights to the code to the company, and then the company saying, yeah, you know, we should go open core and charge everybody for the updater. And, you know, plugins, you have to buy them. And we didn't want that. We absolutely disagreed with that. And so we joined the Commons Conservancy, which is a Dutch foundation that exists to protect the moral aspects of the code, so that when I leave or when someone else comes in or whatever happens, the license of the code can't change. We have a procedure in place for removing members of the board of directors who maybe perform badly or do the wrong thing. Because we want this to stay a community project. We think that open source is really the only thing that is going to be able to sustain this planet. And we also started an open collective where people can donate if you're interested. We used the donations to pay for our trademark and for part of the audit. So that money is all very visible what it's being used for. And now I'll talk about Tauri. I'm sorry, I'm kind of long-winded. Please forgive me. Has anyone here ever built an Electron app? Okay, a couple of you. So with an Electron app, you basically have a JavaScript system that it ships with Node.js, it ships with a Chromium type browser and a front end. I mean, that's kind of generally the idea of these apps. Tauri is similar. Basically, we have three parts. We have Tau, which is the part that makes windows. It creates menus, gives you a system tray, figures out the buttons that you're pressing, the so-called accelerators, and that's, it sounds like it's not much, but getting it to work on Windows, Mac, Linux, fractured ecosystem on the planet. It's kind of crazy just thinking about how many different kinds of window renderers you have, and it's a massive work. If you're interested, join the working group. We always need help there. Now, once you have a window, you have to put something into it. So web views, if you haven't heard the term before, are kind of like what you see on a website. It's got HTML, JavaScript, CSS. It doesn't really belong to a standards body, but it is also kind of the technology upon which PWAs are based. So once you have the window, you have to put something into the window, and we offer two things. Well, one right now, and then immediately after our stable launch, we'll give another one. One is the web view. So you inject a web view, and then you can populate that web view with your content. The other is a pure GL window managed by EGUI. So you can even, like, if HTML isn't your thing and you just want to write shaders and build your interface that way, you can do that with Rye. But I mean, other projects are also using this. We built this out so that, for example, Dinosaur, which is an app construction kit for Dino, is using Rye for its desktop apps. And then Tauri. So Tauri is kind of like where all the pieces comes together. It gives you the API to interface with your file system or whatever, and provides a structure for integrating plugins, working with the file system. It has a full CLI. It also has build tools, so that you can build and bundle your final apps. You can sign them. You can have them actually made in full CI. And there's a lot of features. Like, for example, you can use Node.js to set up your app if you're familiar with doing website construction that way. But there are other Rust options. So you can stay entirely in the Rust ecosystem if you want to use something like Dominator or Vue. We have multi-window, we have headless, there's notifications, there's actually a pretty elegant updater that solves the Windows updater vulnerability that Electron has, because we introduced an additional signing mechanism. So we provide a secure context, like I was saying, Mac OS, Windows, and Linux. And we haven't found a web framework that doesn't work. If you do, let us know. And if you want to integrate your web framework with Tauri, then we have like I was saying, a Create Tauri app. So I'm going to try something. I don't know if if this is going to play back. Is my audio going to come through when I play from the Mac? No? All right, well then I'll just put this link. I'll tweet the link later. It's a really great intro to 100 seconds of Tauri. So let's just go back. Right. What's next is the stable 1.0, like very, 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 very soon. One of the things that we are really happy about that'll be fully announced after we launch the 1.0 is that we've put together a partnership with Cloudflare, and they've granted us unlimited workers so that your open source project can use the Cloudflare distribution system as long as your project is using the GitHub updater service. So basically what that means is you can distribute at the edge to all locations on the planet that Cloudflare can provide to. We're like one step away from WebRTC. We have already proofs of concept, so it does work as bound to other languages like C, Java, Python, Go, Nim, take your pick. So you can actually harness the Tauri app from a different language. And we're planning on bringing out a series of books. But what I really want to show you is a demo. I think I have like 5 minutes or something. So I'm just going to, you can see this in the back of this room, or should I make the text bigger? Is it okay? Okay. Cool. Where's my mouse? There we go. Oh, sorry. Okay, so we're going to just run npx create Tauri app. And I'm going to choose my personal favorite is with Vite, and I'm going to add the API package, and I'm going to choose Svelte TS, and it's you know these create projects. Yeah, so that was about 20 seconds. And this might take a little longer because we have to pull fresh packages, but I'm just going to do npm run. So what do you need to run Tauri? Basically, you need the Rust compiler, which comes along with Cargo, which is kind of like the npm for Rust. We've got full install tooling on our website. Demo gods, hello. Let's do it again. There we go. So basically it's pulling in a couple hundred packages, and a lot of this is dev tooling. I would say about a third of it is dev tooling. And while we're here, I'll just open up the source. And here we go. Hello TypeScript. So this is your Tauri app. I'm just going to cancel that, and I'm going to do a run Tauri build, and then we're going to just see. Yeah. Let's change the identifier, Tauri bundle identifier, Tauri bundle identifier. And this is actually kind of an interesting little feature. you do know if you bundle an app on, for example, Mac OS, and you use the same name as some other app, it's probably going to try to put all of the app data in the same folder. So now what's happening is we are compiling all of the actual dependencies required for the app. And again, this is the first run. So after the first run, things are cached, so it's an order of magnitude faster. And you might ask yourself, hey, why is this taking so long? I've got stuff to do. But the thing is, by running this compilation step ahead of time, you're getting a much smaller bundle size. And I think this is also something that we're seeing in a lot of the modern JavaScript tool chains, is they're actually using Rust to compile things faster and smaller. And I think that is a small price to pay. Like if you consider that my device is now spending 45 seconds to, yeah. Great, so it finished, it took 1 minute, okay. So my computer took 1 minute to build an app that is about maybe more than 1/10 the size of some other app. And now I'm just going to go into the release folder, bundle, and I'm going to reveal in Finder so we can see exactly how big this is. Yeah, it's 8.3 megabytes. And this is because, if we go back to the where is it? Here. Allow list. So basically, I'm saying everything. Give me the entire API. I'm actually going to turn that off just to prove a point. I'm going to turn that off and run the build again. Now, if it's faster than a minute, I think I'm pretty happy with that. And what you're seeing in the background, too, is we're actually creating a proper app. Now, I'm not signing it, so if I send it to you, you'd have to get into that. But I don't want to waste all your time with me babbling here. I just want to make sure that it is smaller now. Right, there we go. It's 5.4 megabytes. It took half the time. So really the point I want to make here is that it's like Johannes was saying, we have a really great opportunity ahead of us to rethink the way things have always been done, and that's why I was super happy to be invited here to the name of this conf, because we are the ones who get to build our own tools, and we're the ones who get to change the way society thinks about things. And I'm really happy to have been here, and I think maybe there's a little bit of time for questions. I'm happy to answer them here on stage or later on in the day. I'll be around all the time.
Thanks so much, Daniel. What an amazing talk, right? I loved it. I loved everything. I loved the speed, the Rust compilation, and the fact that you pulled down packages from Cargo and it worked on this internet. That alone deserves some applause. You know what I'm saying?
Thanks, guys.
Yeah. And the live coding, I would consider this a high quality presentation, so thank you. We, on Twitter with the hashtag WorkerConf, nobody asked any questions. Does anybody have questions? Now, this is your one chance. Show me your hands if you've got, yes, we have a question. You can ask it and I'll just echo it here.
I think you brought up very well the social responsibility of software. How do you think we can foster it to a higher degree that people take their real responsibility? Because, I mean, software is so powerful, but I think oftentimes people don't feel it. They don't feel how important they are. So how can we share this feeling and this perspective better?
Yeah, he asked, how can we feel the shared responsibility of software on the planet and other social responsibilities? How can we get better at feeling and then practicing it?
Sure, I think one of the big misconceptions about open source is that it's some kind of moral code. Yeah. It's not. Open source is a license, it's a legal implication, you are bound to certain conditions. And I think that in order to address this kind of concern can only be addressed by communities, by having a code of standards. The worst things in the world, from my perspective, for open source is when open source gets militarized. I don't mean someone breaks into an NPM project, steals the email address, and changes the code. That's different. That's hijacking. That's criminal. What I'm talking about is when a software engineer thinks that they should make a statement by removing their work from the common good. And by that I mean, you've seen recently cases where in order to support the Ukraine side of the terrible things happening in northeastern Europe right now, a developer actually modified the code to the point where A, it didn't work, and B, if you were in, I'm not sure. I think if your computer was geo-IP'd to Russia, it actually filled your computer with junk. And that, to me, is the opposite of responsibility. I think that if you have an issue with some corporation, let's say you don't like ICE in the United States, the Immigration Control Authority, removing your code from Chef is a type of protest, but it actually impacts the people that have nothing to do with it. And our suggestion is always take it to the community. And because open source is not a code of conduct, that's why we have codes of conduct in our repositories. And that's why we tell people to either be part of it or to leave. If someone is abusive in our community, we will just say, get out. And from the perspective of corporate social responsibility, the most important thing is that you're responsible. It's not that hard. It's like, be a good person, care about your employees, care about your environment, care about your code, and for God's sake, care about dinner, and take time for your families. I think that's the key.
Yeah, awesome. Thank you. Really well done. That's an amazing presentation. Thank you. I'm gonna let you get off stage and awesome. Hey, we're having a good time so far, right? Yeah. That's good. There's like at least 3 of you. This is great. I have some announcements. One tip for I like to play this game. It's called How Not to MC. Okay, this is how I announce the next thing. Ready? Okay, break time. That's not, so there's a break coming up. This is how I do it properly. There's a break coming up. If you want to MC something, by the way, take notes. This is free. There's a break coming up. It's a 30-minute break for you to socialize, get something to eat, go to the bathroom, do your human stuff, and come back. We have an amazing talk after. You do not want to miss it. It's about building a globally distributed system with all kinds of internationalization concerns and everything. It's really compelling. We'll meet back here at 11 o'clock this time zone, all right? Enjoy the break. We'll see you soon.
To work with databases for building these APIs. And that allows us for like this unidirectional.
I saw somebody demo a Towery app, and it literally brought tears to my eyes because we've all been in this kind of COVID situation where, we've been in business, have them actually made in full CI.
To play this game. It's called How Not to MC. WorkerConf, we are back. Yeah, you know what this sounds like? This sounds like some of you maybe had a little coffee in the he's like, yeah, me. He's twitching, I see. So hey, we're back. There's going to be another couple of amazing talks. You see our next speaker, Lizzie, here. Let's hear it for Lizzie, everybody. You're going to get an amazing talk, and I'll introduce that in just a minute. Before that, some housekeeping. Somebody lost a ring. It looks like a golden ring with some stones in it. So if you check your hands, if you're missing a ring, I have it. I didn't take it, of course. Stop. Why would you? I didn't take it. Somebody found it and gave it to me. So I have it. I am, I guess, the Lord of the Rings now. Precious. And so yeah, come get it. This next talk from the one and only Lizzie Linhart is about how they built a globally distributed headless CMS and all the complexities with it, from testing to elastic beanstalk and infrastructure to internationalization. I'm so excited to understand the full complexity of this, and also works as the principal front-end architect at Storyblock. Anyone heard of Storyblock? I love Storyblock. Yeah, look at that. Their dev advocates are doing a good job. Shout out Facundo and others. Without further ado, my friends, Lizzie Linhart.
Thanks, everyone. It's really nice. It's a really nice day to have a conference and also be here. So I work at Storyblock. Can we turn on the slides? I work at Storyblock as a principal architect, so I'm really responsible for the interface that people use. I'm also from Austria. I come from Salzburg. And Storyblock is an Austrian company, but we're actually all over the world. We also have employees all over the world. I want to talk to you a little bit today about global distribution, about also global software development. And my talk will mainly focus around 3 areas that I learned a lot about in the past 2 years that I've been there. So I will talk a little bit about headless and why that's interesting in the content management world. I will talk a lot more about like global distribution, about how we do software development globally, and also about fully remote working, because Storyblock, we don't have any offices. When I started there, I was like the 15th employee. Now we have almost 200. And there's no offices, so there's a lot of challenges in working in this fully remote way, and a lot of lessons that I also learned in the past few months and weeks. And in my team, I work with a lot of Brazilian people. So the main part of the product team is actually in Brazil, but I also work with a lot of people in like Berlin, Portugal, a few of them in Europe. And there's a lot of challenges in working across many time zones, so that's a little bit what I want to talk about. But let's start kind of what actually headless and a headless CMS is. Has someone used Storyblock before? 2, 3, a few people? Is someone using like very traditional CMS systems like WordPress or like, yeah? What? Okay, I don't know it. Okay, I mean, the core of the traditional CMS is that it's very integrated, it's very coupled. You have the front end and the back end together. And you can also extend that. You can write your own plugins, you can change things in the CMS, but you really need to know the CMS really well to extend it, to make it more, do more of what you want to do. And with the headless CMS, we have a lot of headless CMSs now. There's also other ones, of course, like Contentful or like Strapi. They're also really amazing. And in the headless CMS world, we really decouple a lot of the stuff. So a headless CMS, it really focuses on providing really good APIs. We give your content in an API interface. You have the admin interface to manage all that, but you can also change your content through other stuff, through like automations, through management APIs, and you actually can like quickly translate or adapt your content in a very flexible way by using the different APIs we offer. So the core is really that we don't make a choice of like what you use the content for. You can of course build a website with it, but you can also use it for apps, for mobile phones, for like dashboards, like we have car companies using it for like car dashboards, car information, or like in the virtual world in like any kind of virtual way. And for us, the content, what comes out is like a JSON format that you can change, adapt, and also create lots of different versions of whatever content you're using in like different languages, in different countries, whatever you want to do with the content you have. The first lesson I learned in that headless content management software development is that the customer really decides what you build. So we think we decide what we build, the product team and the managers and whoever is involved, but in the end, the customer who is paying the content management system, they don't want to maintain their own servers, and we heard a lot today about the cloud and like how it's really expensive, but for us, it really enables us to build what the customer wants. And that's, they want really fast APIs, they want really fast images, they want to manage their content in different countries, in different ways. And they also don't want to build their own interface, they don't want to maintain the interface, they want to have it improved and they want to have like a nice UX, but it should be provided. They pay for us to develop a really nice interface for them. And yeah, they want nice integration, so we also build a lot of SDKs into different things that work really well, so they can like build on top of that API really fast whatever they want. What allows us to do that? So we don't manage all those servers by hand, but we use the cloud, of course, and we use a service that a lot of people probably know, which is Elastic Beanstalk. And Elastic Beanstalk, it allows you to really quickly create different environments of your application. So it has everything included. It does load balancing. You can have different environments. You can have different environment tiers. It's really good at like red-green deployment and deploying different versions of an application. We have content that lives in the US, we have content that lives in China, we have content that lives in Europe, and the customer, he of course wants also to choose where that content lives. Like an American company, they have some restrictions, so they need to be able to say, well, my content needs to be in the US, or my content needs to be in Europe. So that's something we need to offer if you have like global customers that have also these restrictions of where and how they manage their content. And what's also really nice is that it automatically provides you with really good monitoring and security. So you can really monitor the different servers, the different environments. They also do a lot of security updates for you. So for us, it works really well because we have a few DevOps people really, really good in deploying these different versions of the services so for example, we have an image service that lives in different instances. We have the content API that lives in very different instances. We have the management API, and they're all kind of decoupled and they have different load balancing and different usages. And you really need to optimize and monitor how high the load is and see if like you need to change something, if something is really unperformant, if you need to make these performance optimizations to make it faster. Yeah, so that's really like the core of this whole product we have is building what the customer wants, and that's like many locations, many different versions, many languages, and that really, really fast. And we cannot do that without cloud services. It's really hard to do without cloud services, to be honest. But when I go more into like the actual software development at Storyblock, when I started, I was like the 15th employee. Now we're over 200, and we have a lot of like global employees, and we also have a lot of global customers. And doing this kind of global work, it really requires a lot of adapting and iterating and seeing what still works and what doesn't work. For Storyblock, from the beginning, they started with a lot of trust. They say, well, we hire really good people, but we also trust them a lot to do their work and to work in a flexible way. What's the advantage of that, of having this like global way of working? We can hire a lot of really, really talented people from everywhere. So I work with a lot of really talented Brazilian developers, which is really nice, and I also learn a lot from them because it's also a different culture for me, but it's actually really, really amazing, and I actually also have the feeling of a team in working with that team. This global way of working, having customers all over the world, it's quite challenging in the way that you need to have a lot of support. You need to have a lot of support in all of the time zones. So the way our support works is that we have actual people in like different time zones and manage that. And that way we get like 24-hour support for all the different areas where we are. And if you want to sell that product, of course, it's also good to have an employee who's close to the person who is buying that, who understands the culture of how they want to manage contracts, of how they're buying that product. So you need to have people selling the product understanding like who they're selling to. So that only works if you have the employees in those areas where you want to grow and sell the product. It gets really complicated when you get to like HR process and hiring and like making everything the same for everyone. The way Storyblock solved it is that it is giving a lot of the rights Austrian workers get to everyone. So all the other employees, they have the same rights as the Austrian people have, because they said, well, that's a really good basis because we have a lot of good stuff in Austria. What's also really limiting is when you come to like time zones and language barriers, when you have people who are still learning English, and when you have like in one team, you have too many time zones, it's really hard for people. So you need to be really mindful how you mix those teams and how many time zones are in a team. Because 2 or 3 time zones work, but if you have a lot of different like time zones all around the globe, it gets really hard and really limiting. Yeah, so it's really a lot of figuring out how to work in that team and if the time zones work or if there are improvements that can be made in terms of those limitations. This is not really a new problem. So there's a really great paper from like 20 years ago, which is called Tactical Approaches for Alleviating Distance in Global Software Development, which kind of talks about the same problem, that if you add distance to any working relationship, that's the graph on the right, it has a negative impact on communication, it has a negative impact on coordination, and it has a negative impact on control. So you need to really look at how you can improve this negative impact that distance is adding to those 3 factors. And the main one is really communication. So communication with someone who you only have like 1 hour of overlap with is really, really hard, because then you need to pack a lot of synchronous communication in this 1 hour. And then if the communication is not going well, if a lot of miscommunication is happening or no communication is happening, then you lose a lot of the control and a lot of the coordination, and that's where like the things start going wrong. And that's kind of the 4th lesson. Today we can work really asynchronous. We have GitHub, we can review code asynchronous, we can write people on Slack and they read it the next day. We have a lot of great tooling and technology to do this work in a global way. But there's still a really important part in synchronous communication, in talking face to face, and also maybe meeting in person. And yeah, for me, the lesson there was that you need to, if you have really little time overlap with the people you're working with, you really need to focus the synchronous overlap that you can have with them on really important things. So you could have like really nice team meetings, you could have like one-on-one meetings, but everything that can be done asynchronously, that's not important to do synchronously, you should do asynchronously and focus really on improving this little time that you have together. When we talk about control in global software development, I don't think you can ever have full control of like a software team. Some people always do like kind of what they think is better. But for Storyblock, the approach kind of is that we put a lot of trust in like the individual teams. It's trusted that the employees make really good decisions, and there's also not a lot of micromanaging happening. So since it's fully remote, there's no offices, there's no like actually like you need to be here from 8 to 4 and we look at that. It's very flexible, and then if you say, well, I'm gonna go pick up my kid from school, that's fine as well. But if you think about software development, Scrum and Agile, it works really well because it's a really proven concept in software development that focuses on talking to the teams and talking to the people actually making the work. And through the retrospectives and the reviews, you see what can be improved and you get the feedback. And also in like the virtual environment, this is really important that you talk to the people who actually are in this virtual work environment and keep these processes and keep asking people directly what do we need to improve to make it better. There's also a lot of research that if teams grow really large, they become productive. So what really helped us is if the teams are bigger than 5-6 people, at some point you need to break them and make them into smaller, more functional units. And these small team sizes have a really positive impact on the people and on those teams because they're more connected. Yeah, so that goes into coordination. So how do you coordinate global teams? How do you coordinate 4 teams, 5 teams? How do you coordinate 5 people in 2 different time zones? And there's another really good paper that really looked into that. What they did is they looked at the Slack logs in several years in the Norwegian team and in the Chinese team. That's what you see down there. And they looked over like a few years. They looked on how the different people in those like global environment used Slack to coordinate their work, to get their work done. And what they found is really interesting. They found that a person's role is directly correlates to how much time this person spends in meetings. And meetings aren't just video meetings. Meetings are also unscheduled meetings is what they call it. And unscheduled meetings is what you can have on Slack, that you write someone and then you have a 5-10 minute discussion about how something should work or something doesn't work. And they found that like normal people in teams work around like 8 hours in a week in scheduled meetings and around 9 hours in unscheduled meetings. So we spend actually a lot of time in meetings, but the higher you go in management, like technical leaders and then just like product owners, managers, they spend like even more time in meetings. So a higher manager can spend up to 5.5 hours per day in a meeting, and they're in video meetings and Slack meetings, and it can be very tiring. So that's why if you work in this fully remote environment, you need to make sure not to do everything in like video meetings and constantly have more and more meetings, because you do that all the time and you also need to get some work done. So what we do is we often block like our calendars for focus time, and we just say, well, we're not available for 3 hours or 4 hours. And then people know that and they don't keep sending you messages. And you can also do a lot with notifications. But you need to be aware also of this unscheduled meeting time, of this time you have when you're on Slack and someone sends you questions and questions and questions. And to sometimes just say, well, I'm not available at this point. And this chart is also from this paper. It shows on the bottom the team size. So on the left is like a small team size, on the right is a high team size. And then the y-axis is the value for the people, for the role team size. So the red line is developers. So you can see when the team size grows, the value of the meeting really is and has a negative impact for developers, higher impact. And the blue line is kind of the testers. This is like to say that Slack works really well for us. It really helps coordinate if you work across many time zones with many different people. You have never met them. So there's a great book that's called How to Build a Connected Culture with Virtual Teams. And they write there, most anyone can learn to be a great virtual employee. The top skill to learn is setting a healthy boundary between your work life and personal life and building relationships virtually. If you work a lot from home, or some of our employees, they work in co-working spaces, but most of the people, they work at home. So it's really important that you learn to differentiate that. And I think a lot of people learned that in COVID, that it's not great for everyone to work at home. But I still enjoy it, and I learned to set my boundaries of how I work and when I work. And when I stop working, I'm also not available anymore. I removed all the Slack apps from my phone. I don't check my emails. I have working time, but I don't need to be available 24 hours. In building relationships, there's a lot of things you can actually do to build closer relationships with people that are in Brazil. And that's kind of also what I learned over the time, that it's really important not just to be hyper productive and be available all the time and build more and build faster, but to actually have some fun, get to know the people you're working with, and sometimes also slow down and lead by example. So to just schedule some game meetings, to just highlight some people, to make some learning events where people can share what they learned, where you can highlight specific developers that are really good at different things. Yeah, it really makes a difference. So that makes a difference for the teams and the developers I work with, and they really, really enjoy having this, not just all the time functional meetings and communication. Another thing that I noticed a lot is we've grown really, really fast, and we had to onboard a lot of people. We had to build a lot of onboarding processes. And what you need to realize then is that people have learning curves when they come into a company. You can hire a senior developer, but that doesn't mean he's productive instantly. Actually, the research shows it takes people between 1 to 3 years to learn and gain all the domain knowledge and all the organizational knowledge to become fully productive. So you can't just put 5 senior developers in a team and expect them to do the most amazing work next week. It's not how it works, and you need to adapt to that. You need to give people time to learn. And you need also, if you're there for a longer time, you need to find some ways to maybe shrink that learning curve for people. Have buddy systems to help people learn a bit faster, having really good documentation, or by having examples they can look through and having more internal learning that helps people gain this organization knowledge, this domain knowledge they need to work on a headless system, for example. Yeah, and one big point in that is you have a small team, that you have one big epic when a new person comes in and where they have to work really closely with another person. So don't put them on a separate task, but really put them on a big task with someone who's been there longer. So they can start really learning to collaboratively work on that thing and learn how to work remotely in a software environment. So that kind of goes to the last part. And that's kind of building cultures. So for companies, of course, it's really important to have a company culture and to have a lot of values. But there's different ways we build cultures in working. So we have a national culture. This is a really, really strong culture that we can have also in a company. If you're an Austrian company, you have an Austrian national culture that kind of unites you. But it's not actually that valuable if you have a global company, because there's many different national cultures, and there's not that much to build on. If you say, well, in Austria we do it like this, and in Brazil we do it like this, and then we start fighting. So to build company culture is also important. For us, a lot of the company culture is centered about working fully remotely, about working in a flexible way, giving people the freedom to say, well, now I'm going to have lunch or go for a run in the afternoon or pick up my kids and then I'm available after. It's not micromanaged, and the way it works is in a flexible working environment. And that we have a lot of trust in that people actually do their work, and people actually do that. People enjoy not being micromanaged and told exactly when to do what, but to do it in their own way. The next even stronger culture is, of course, the professional culture. That's why we're here today. There's a lot of developers, and it's really great to talk like to other developers about what you think about that profession, and it can really unite you to share your opinions about the tech community or about a framework or whatever you do. The professional culture is really strong, and it's really, really uniting. Also in software development teams, people really enjoy to share things about a profession, and it can help connect people more. But the biggest part of that culture building is actually the team culture. So if you have a team, you can actually influence a lot how the team works, what your team culture is, what you value, and that makes a really positive impact on the people you work with. And that's the strongest point where you can make a difference. So I can try to change the company culture or say, well, in Austria it's like this, but what really brings value is if I look at the team and look at how I can work better with the team. So to look at the team not just as some people who work together, but really to look at it as of like we can build a culture, we can build our own like team thing, and that's how we work in the team. And a big part of that is being transparent, having different channels where all the people in the team get the information, also to give them the possibility to share their opinions, so maybe also anonymously in retrospectives, to build whatever you're building with the other people and not tell them what to do. Also respecting each other, asking questions, also getting to know the people you're working with, having one-on-one meetings, having coffee meetings, to learn actually who this person is, and being empathetic. So that is also something I noticed, like for us, if like there is like a emergency in your family or like a health emergency, it's not really a problem, and we can just say, well, I'm not available today or tomorrow because of this, and it's very open, and it's okay to have that. But that's something you build in a team in a kind of way where you say that's okay or that's not okay. And that's something you really can influence. And I noticed that a lot of these things, they only happen if you take initiative, if you go and make some team building meetings, if you start some initiatives to do games. You can't force people to connect. They have to decide them by themselves. But you can lead people to try to think more about what the team culture is and how you connect and are a better team. Yeah, so that's kind of my talk. You can really go and check out those papers. They're really, really good. And thank you for listening.
Thank you, Lizzie, for this talk. It was a really special talk, especially the part I liked how, and this is one thing in particular I want to highlight is there was an equal amount of like technical expertise, but also the looking after the team and building culture. It was a great balance. So thank you again. Can we hear it for? It's incredible. So there was no questions again on Twitter. Hey, all of y'all's tweet game needs some help. There was no questions on Twitter with the hashtag WorkerConf. Some of you maybe do WorkerCon, I don't know. But if you have questions, show me your hands. Now's a good time. There we go, one question over there.
Yeah, I think a question. If you are working globally, and how do you make this team building meetings? It's not like when everyone is on the same location to make fun and make the team building. How can you do this remotely?
There's actually like a lot of stuff you can do remotely, a lot of games you can plan. What I do is I use these overlap times, like with the Brazilian team, we have like 2 hours of overlap. And in these times I plan like meetings like 2 weeks ahead. I'm like, well, we will have like some kind of game interaction meeting where we actually play this game or we do some kind of quiz or like, I mean, that's something you need to plan as a lead or a manager to say, well, I'm taking some time to prepare this for the team. But when we do it, they really enjoy it and they're really like, yeah, let's do it again. You shouldn't do it all the time, but when you do it and you plan it, people are really happy about it.
Awesome. Another question over there.
Yeah. Do you also plan in-person meetings that the Brazilian guys come to Vorarlberg or vice versa?
Yeah, we have some in-person meetings, but across continents it's quite difficult to plan. So what they did is that they had a whole like Brazilian meeting with all the Brazilian employees just like a few weeks back, and we're having another like European one where a lot of like the European employees meet. I think at some point they want to do like one where all the people are, but that's really, really difficult to manage. So now it's more focused on like continents and similar time zones.
And on the onboarding, you have the developers which you have never met in person, right?
Yeah, most of the developers I've never met, no. Yeah, we have, in the onboarding process, we have a lot of buddy systems. And there also we have like small teams of like 5 people where you work really, really closely with another developer while you're onboarding. We have also a lot of onboarding processes. So we use an app for onboarding that has a lot of the general company onboarding. And then I wrote a lot of the technical onboarding they need to start working in that code base.
We'll take one more question, and then Lizzie will be here in the breaks to talk more. Yeah, you.
Thank you so much. So in terms of, I imagine maybe the attrition can be an issue when you're trying to manage globally distributed teams. And you mentioned some tools that you use. Are there any apps that you might use for business games, etc.? I'm just curious how you actually are able to sort of expand the geographical barriers.
You mean now for games or for coordination? I mean, if you work in a global way, I mean, I already mentioned Slack, that's a core tool. We also use Notion a lot, of course, for documentation. Also, when like people change or people leave, we still have like the knowledge there. We also use like a lot of like other tools, but the most important ones are Slack and Notion.
Cool. Slack and do you work at a tool by any chance where you're trying to get her to say the name? I'm just joking. Yeah. Yeah. Quizzes and games he mentioned. Any highlights there? Can we get the microphone working for Lizzie, or is her talk's done? Yeah. Here. You can use this one.
For apps, there's actually not, like, I think there are a lot of companies that provide like team building events, which we have tried, but it's like, it really depends. So it's more like planning yourself what works. Like there's a lot of online games you can play together that work really nicely, but there's not like a big provider, like you would say Slack or something like that, but you really have to research depending on what you want to do. If you want to do like a breakout room or you want to do a quiz, there's like dozens of things you find.
Awesome. Let's hear it for Lizzie one more time, everybody. That's wow. That was a really good talk. I got so much out of it. In fact, I took notes. This is how you know it's a good talk. Like this one slide with you're welcome to get. We can get the next speaker up on the stage, Konstantin, wherever you are, if you're still here. There he is. Thank you again, Lizzie. I took notes. This slide here, where it's written on the slide. Lesson number 8: don't stress over everything. Have fun building and laugh with your team. Slow down and lead by example. I read this, I was like, dang, yes, more. You need to like frame this and put it on Slack or something and pin it, because it's very easy, especially when you're passionate about building something. It's so easy to like, I need to hustle and get it done. But at least in our case, we really don't. we have runway, it's all good. And really what matters for engineering culture and vibe is to just enjoy right, I think. So that was, thank you, Lizzie, that was especially such a potent slide. You were asking about tools, just as he sets up. So we're also fully distributed, same, very similar culture, autonomous, urgency, and ownership, and all of that. And we use a tool called Donut that helps a lot. It's like a Slack bot that grabs two random people and says, okay, meet. And it's if you've never met the person or you can't find a topic to talk about, it'll generate a topic for you. What's your favorite thing about remote work? Do you have any pets? This kind of thing. So Donut is cool. We use that. Also, we sometimes if you want to play games, there's a game called Scribble, Skribbl. Really cool. It's like Pictionary for I see him nodding there. Yeah, it's great for distributed teams. All right, our next speaker. Look, I'm excited about this talk. You know why? There's a there's a company called PlanetScale. Okay, you get a database that can apparently scale to planet level. Wow, how cool, Planet. Can you imagine? This talk is about IPFS, which is interplanetary file storage. Woo! This is like what? Like just by the name, I'm like, are you going to be sending stuff to Mars using? So I'm like hyped. You hyped? This like shit. IPFS, everybody. So this is going to be a primer. IPFS and some crypto and some Web3. I'm excited because you know what? Anyone else feel like FOMO about Web3 and you're just like, I see hype, but I don't know if I should. No one. Come on. And now you're like giving me pity hands. Yeah, but I see. Yeah, that's the one. They're all Web3 experts. Yeah. I see Tom's over there. Like me. So I personally, I see a lot of hype. I don't get most of it. I'm a bit ignorant here, so I'm really excited for this talk. Everybody, will you give the warmest welcome to Konstantin?
I can do it. One, two. Amazing. Three. 1, 2, 3. Make no problem. Simple. Yeah. 1, 2, 3. Perfect. Then I'm speaking with you like that. And thanks for an amazing introduction about space. We are literally just announced our first node to be in space last month. So it's actually literally interplanetary, but I will guess there is a lot of stuff is happening in Web3 right now. But in the same time, developing stuff in Web3, you just get overwhelming amount of content, overwhelming amount of information, but you are still kind of losing the track of what's happening every day to day, what are the projects appearing, what are the projects disappearing. So what I rather would like to focus on is what matters for Web3, and what matters not only for Web3, but what matters for everyone else, for everyone here to know about it or to think about that can change the way you work, that can change the way you think about something, or that can help you working or help you today life. So first of all, I would like to introduce you to a company a little bit. Give me a hand, raise me a hand, someone who have heard about Protocol Labs or IPFS or about Filecoin. Okay, who of you heard about Web3 in general then? And who of you ever touched the topic of storing something on Web3? How the storage in the Web3 works, how they approach it? Oh, that's amazing. You're an amazing audience then, and I would just give you a brief. Are we doing what the Protocol Labs is? Yeah, sure. In 2 minutes as well? Well, but 1, 2, 3. Oh yeah, that's better as well. And do you still hear me like that? Amazing. So first of all, Protocol Labs by itself is a decentralized organization, if you can say so. So Protocol Labs is we're actually aiming to do something good for everyone, not only just for the sake of a company. Thank you. And in order to do so, we are developing multiple tools. And first of all, I will go you through the concept of IPFS and Filecoin. So you know all this history, you know probably even better than me, but essentially we were transitioning from the internet, where we have wires and networks, to the Web 1, which was read-only. It was static websites. You cannot interact with them. You just upload content and it's there. Then we transitioned to Web 2, which was read and write. It enables us to be an interactive in the internet, and that's what most of the tools you're using day to day is about. It's about Web 2, you can read, you can write, but is that it? So I would say that the Web 3, or the essential part of Web 3, is enabling trust in this read, write, trust sequence. It's a next evolution of web where trust has been an operative thing, and it allows you, or it is achieved through verifiability and a whole bunch of underlying primitives that builds up on top of the technology that allows you to enable web which is verifiable and trustful. What does that mean? I mean, we are all transferring from somewhat centralized solutions of the web to a more decentralized and hopefully to the distributed space. So centralized, and why everyone bash it, I mean, you all face the centralized solutions day to day. Google, Cloud, Facebook, Instagram, all of those are, first of all, single points of failure. Moreover, you are really locked into one particular solution, so you cannot really switch from this solution to this solution. The migrating is very hard. Changing a provider is very hard. And essentially, especially in the social apps, you are essentially locked in an app because all your friends are there. You cannot really move data from one place to another. And the data, in the end, which you put into the app, which you believe is your personal, is still monetized by the data monoliths, which store it and makes the best use of it. So instead of having these central points of failure and data silos, we are believing that the web should be decentralized, and moreover, it should be distributed, where the users power the service, not the other way around. Not the service powers the users, but rather users have the control of their own data. They can freely move it so that there is no censorship resistance. There is privacy inbuilt by design, not by what a certain tool offers you, because, well, in the WhatsApp, okay, now they enabled end-to-end encryption, but it was a long time not in place, and you couldn't choose that because you were still all the friends and families there, and they still somehow utilize your data. And it should be also self-verified and non-siloed, so that you're not locked into a particular tool. You can self-verify if the content you're working with is what you're expecting to work with, and it should not be handled by someone else, but by you or by the protocol by design. And going to the decentralized space, the beauty of it is that there is no one central solution or one central stack which does everything. Instead of that, we build multiple building blocks, and whoever builds their own solution or a project can utilize different blocks, and he's not locked into any particular project or a solution. Instead of that, you can utilize different blockchain layers, you can utilize different side chains, you can use different environments, you can use file storage, you can use indexing, querying, etc., etc., etc. And for whatever project you are building, you can combine these different pieces together, find them in the most suitable spot or architecture you enjoy, and then just build your protocol or project on top of that. We also contribute as IPFS and Filecoin to the file storage layer, but we are not only file storage, we are also providing off-chain data protocols. We have our own blockchain one layer, and we enable people to have the pipeline of a data storage in the Web3. And we believe that in Web3 stack, verifiable data is essential to a truly distributed system. And in the next 30 minutes, I will walk you through concepts of IPFS and Filecoin, what is peer-to-peer hypermedia protocols, and I will tell you that files and folders are not boring, and they're actually super exciting to work with. So first of all, let's go to the IPFS. IPFS, thanks for the introduction, it stands for Interplanetary File System. So let's break that down. So first of all, file system is the usual files and folders. And interplanetary, we understand it as distributed. So there is no central server, and it's resilient and online first. And why it matters to be like that in an interplanetary scale system? Because imagine we colonize Mars at some point. And if we continue to use the same tools as we have right now, including Google, Facebook, any call which you want to do from Mars will take an hour to get to Earth and backwards. And going back to Earth every time you need something on Mars is just very awkward and stupid. But imagine instead of having to talk with a centralized solution every time you want to do something, you just have a distributed network, which if anyone has copied the data you wanted on Mars already, you can just request it from him directly. And that's exactly what IPFS does. It builds a network of communication nodes, which allows you to retrieve the content not by a central authority, but by whoever owns or has the same copy of it. Addresses the content by what it is instead of where it is. So you all are familiar with computers and how the files and folders work there. So in order to find a certain file on your local machine, you go to a file, to a path, to index, you found it. The same works in Web 2. Essentially, when you want to download an image of a cat or a meme, you go to a domain, you go to a path, to there is your image. Instead of that, we replace a folder or a file with a content ID. So we create for any content you upload to the network a unique identifier, which is called CID or content ID, and it provides you pointer to the exact content which you have, whatever it is. And to give you a better example of how it works, imagine a friend tells you, hey, you should read this great book. And instead of telling you which book you should read, he tells you, you can find it in New York Public Library. You go to section 9, to the bookcase 3, top shelf, first from the left. That's already awkward. Okay, but you trust your friend, you think that the book he recommended is great. So you go to the New York Public Library, to the section 9, to the bookcase 3, top shelf, first from the left. And the problem is it's the same book as you had in a backpack. And that's super awkward. And that's exactly what our internet is doing to us right now. Instead of telling you, oh, this is a content, it tells you where to go for it, and you don't even know what content is inside until you reach it. And instead of doing so, there is a way, way smarter way to do it by creating, first of all, you can use any content in IPFS network, and you create a cryptographic hash function, or SHA-256, and you create a content identifier for it. It's a unique code which belongs to the same content, and it only points to the exact content it is. If any bit inside the content changes, the cryptographic hash function would be completely different, and it's a one-way function, so you never know what you are working with until you actually downloaded it. The beauty of this structure is that whenever you work with the same content, it is the same CID. What does that mean? Whichever computer you use to create this function will always generate the same code for the same object, whether it's an image, whether it's a video, regardless, whether it's a file folder. So the same content is same CID, and content ID can be reproduced anytime from the original content. Also, the beauty of such design, so whenever you request a content by a CID, you can always verify what you have received by creating a CID again of the object. And if it matches what you originally requested, then you are working with the right content. If you are receiving a different CID from what you requested, then there is a flaw, there is a malware, something is problematic in the network. And you can not only work with the content as like files and objects, you can also work with the folders. So folders are essentially kind of file which just lists other files in it, and the core principles for IPFS remains all the same for any structure or any data you use with it. When it comes to folders and structures, you can literally operate within IPFS with the folders and structures with the pointers and the CIDs. So on the bottom, we have 4 different images, and they are grouped in 2 different folders, and they are grouped into one big folder which has a root ID. And every picture and every folder inside the system has a unique fingerprint, which is exactly the CID I was talking about just before. And we have Merkle DAGs, direct acrylic graphs, which are data structures in which each node is content address. So whenever you point into anything in our IPFS network, you actually have the CID of the content. And you can point not only to the object, you can also point to the folders and find the content whenever you need, however you need. The beauty of such system is when you create a folder structure which with the content which already on IPFS, you just point to the same CIDs because same content, same CID. And you essentially can deduplicate the whole internet because the copies of the same files are the same things. So you create a new folder, you have the references to images, but these images already live on IPFS, so you just do not need even to upload them. You just have the references to them, and they're available on the network already. And this also brings you the verifiability. So if the content changes, the CID changes. At any point of time, you can check whether you are still working with the same content you're expecting to work or not. And that's deduplicating the whole internet, essentially. You don't need to store the same images over and over again providing it in many, many countries and places. You just rather store it the minimal required amount to do it redundantly, so the content persists on the web, but then you can just retrieve it from the closest node instead of really going to a server and downloading the content from there. In order to this system to exist, you need to have a complicated system of content, of peers, of swarm, and it's also all handled by this open source protocol. So first of all, in order to work with an IPFS network, we have a swarm of peers. So everyone participating in this network is essentially a node and has same properties as everyone else. But they should all be, first of all, discoverable, and they should be routable or reachable. So whoever participates in a network and provides content on IPFS has to be discovered, to be pointed to, and need to be reachable through the network so that at any point of time you can discover all what's happening in the network and receive the content which you're looking for. For that purpose, we have distributed hash tables, and I believe me, that's the last 2 slides of deep technical information, so you're not too down or not focusing anymore. But this distributed hash tables is essentially what enables us to organize the whole network, not by maintaining the one list for everything, but rather creating distributed hash tables for a small group of peers, which are maintaining it as a phone book altogether. Imagine, and I can give you an example of maintaining it all together. Imagine you and your group of friends sharing the same phone book. So you have a name of a person and a phone number, and you're maintaining it together all across your group of peers and stuff. The reason to do so is because you don't need to add duplicated information. Whenever someone meets from your peer or friends a new friend, he adds it to the common shared book, and then everyone had the access to it. And it's exactly how distributed hash table works. It provides you the key and the value to point it to. And peers, every peer in this smaller group can, first of all, query the DHT, so they can discover the peer ID, which provides specific CID, and you can understand and trace what's happening in the whole network. And these smaller DHT tables are maintained by a group of peers, so if someone is requesting information from a peer and it doesn't have it, it asks the nearest DHT table, hey, do you have it? If they also do not have it, they point it to the probable, most likely other DHT table, and that's how peer discovery or content discovery happens in the IPFS network. And distribution of the CIDs across the network is happening in a logical way, so that you don't need always to query through the whole DHT tables of all the peers existing in the network. You rather is able to point where are the most likely location of the next CID to a peer, and just go with a higher probability to ask these DHTs instead of the whole network. So let's summarize that a bit. First of all, you have one CID to rule them all. You have a CID for content, folder, IPNS, nodes, network. Everything could be described by a CID, and everything could be understood by a CID. So whenever you ask, hey, give me this CID from IPFS network, it will point you either to the content, to the folder, to a pointer to another content, or to the node itself as like who runs it and who owns it. And then you do not need to know where it's stored. So whenever you have a CID you want to retrieve from a network, you don't need to go to someone and tell me, you should have this content, please give it to me as a server. No, you just ask the whole network, hey, network, do you have this content identifier? And if it has it, it will retrieve it to you regardless if it's coming from a peer, from a DHT, from IPFS nodes, from Filecoin, from AVS, from many, many more. Whenever you use CID as a reference, you can request it for the whole network, and people can retrieve it to you back whenever you need it. So that's like how all the architecture works. And let me tell you about how it works in the wild. So all of that before was like a theoretical concept of how peer-to-peer networks work. In order for you to actually utilize the system, so first of all, obviously, you can run your own node. Then you can retrieve your content from there, but if your node is too far or goes offline, there is no reliability or redundancy. So then you can also run a network of nodes, but then you are also facing the problem of infrastructure team and managing of the servers or multiple nodes at the same time, which is also not very convenient. You can also pay a pinning service. There are existing solutions like Pinata, Temporal, and Fura, which can pin the data to IPFS nodes for you in our network already. And in the end, you can hope that your content becomes popular enough and enough people copies it so it becomes reliably accessible over time in the network. But does that all sound to you as truly decentralized and reliable solution where you have to trust someone to actually store your data? Not to me. And that's exactly where Filecoin comes into place. So Filecoin is a storage designed for Web3 from the grown up. Filecoin is based on top of IPFS, so it utilizes the same CAD pointers and content addressing in the web, and it's compatible with IPFS and Web3. It provides you a verifiable storage via cryptographic proofs, so you can verifiably check whether your content on the network is stored, how many copies is stored, and in the blockchain, people have to submit proofs that they store your content every 24 hours, so it's verifiably available to you whenever you need it. And the beauty of it is that it's also self-managed by an open market of storage deals. So instead of having one centralized solution or one authority holding all the storage capacity in the network, we have more than 4,000 storage providers which committed some parts of their storage facilities to their Filecoin network, and they store the data on your behalf. And at the moment, this self-managed open market is already accounting for around 18 exabytes of total data capacity, which everyone can use and participate to store their own content, their company content, whatever project they're building on top. It could be reliably and redundantly stored with IPFS. And let me tell you about how specifically the Filecoin works and enables all these features. So Filecoin is essentially incentivizes persistent and verifiable storage designed for Web3. Whenever you have a file and you put it to the IPFS network, you have the CAD. The CAD then could be placed into the Filecoin network, and you can make a deal, which essentially is agreement between you and a storage provider that he stores your content for a certain time period. Right now, the Filecoin deal is maximum to 18 months. So the storage provider guarantees that every 24 hours across these 18 months, your content will be available through the Filecoin network. If you want to store it for more, you can just renew the deal after it ends, and then storage provider will continuously store or perpetually store your content and make it available for you for the lifetime needed for this particular storage. Moreover, you can also achieve redundancy, and whenever you place an object to a Filecoin network, it's stored at least 5 times redundantly, so that even if something happens with one storage provider, the content is still persist on the chain, and whenever you see that there is less copies of the content that you desirably want, maybe a 5 or a 6 would be an optimal amount for redundancy, then you can just make another deal and essentially automatically renew for the duration of the content which you needed. And then, again, Filecoin is also agnostic from where the content is coming from. You can also have cloud and CADs in the cloud, and then you can also renew the deal directly from the from the cloud to Filecoin, or you can use other permanent solutions which are relying on probabilistic and unverifiable assumptions. But in a sense, Filecoin enables you to retrieve your content at any point of time, but the content is managed on your behalf by a pool of storage providers across the Filecoin network. And to sum it up, IPFS truly loves Filecoin. IPFS is there for fast and flexible retrieval. It provides you the gateways, the local nodes, the browsers. And Filecoin is there for persistence, which ensures that your content lives in the web and is persistently and verifiably available to you whenever you need it. And to compare it maybe to traditional cloud networks, first of all, we provide the decentralized solution where the addressing on the accessing the content on the web is content-based or CAD fingerprints. It's natively immutable, but we have solutions to add mutability as well whenever you need it. Availability is global, so the whole network of Filecoin is essentially 4,000 storage providers distributed across the whole network, and there is no central provider or central authority who has a large capacity of the data from the Filecoin network. Moreover, the durability is unlimited. You can renew the deal as many times as possible, therefore your content persists on the web, and you can easily transfer between one storage provider and another storage provider. There is no locks inside. You'll still operate with the CADs. You just make a new deal with a different storage provider, so you are not vendor locked to a particular solution. And the quality of the service is incentive driven. So all this Filecoin network is essentially incentivizing storage providers to store your data. So in order to this to exist, we incentivize storage providers with a blockchain reward. And whenever they can prove that they store your data, they get a block reward which pays them all the costs which they are running for. Therefore, the cost of storing content with Filecoin, the same way you would do it with a regular cloud, is at least 100 times cheaper. And that's even an approximation. The actual number is way, way lower. I think we're around 500 times cheaper. But that's like given on a particular case and evaluation how you made it. And that's actually all fully public and online. So all this runs open source. You can validate it by yourself on the chain. And that's the beauty of how you're working in open source in the end, right? So now I will go you through the tools for Web3, or essentially what is available for you right now in order to build with IPFS and Filecoin to improve your protocols and truly live to the open source vision with your content as well. So you can do the Web3 all the way down your project. You can easily enable DWeb. Browser asks for CIDs instead of URLs, or your regular browser can ask for CID via HTTP gateways, which we also built. Then you can load your front end from IPFS. Then you can log in with a DWeb wallet, and then you use storage helper. So essentially, all your app is available online, could be done in a Web3 way, and also the things could be done through IPFS and Filecoin in order to host the website, store the content of the website, verify the retrieval, and we are also integrated in multiple browsers or have HTTP gateways, so you can interact with the IPFS network directly from your browser. If you're using Brave, and I would recommend using Brave, by the way, it also has a native support to IPFS inside their browser, so they have the node running whenever you open Brave, so it can resolve IPFS CIDs directly in the browser straight away. And whenever you want to build some of this infrastructure for your particular project, there are multiple fancy cool tools which are available for you whenever you want to build with it. So first of all, I can recommend this Web3.storage, which is essentially a general IPFS and Filecoin storage. It's a very easy web API, and you need literally change 2 lines of code from your original way you're working with the cloud to use it with Web3 and IPFS and Filecoin. It allows you to create CIDs, to point the data to a IPFS network, and to pin the data to Filecoin network. And the first terabyte you use with Web3.storage is completely free, but even after this terabyte, it's at least 100 times cheaper than to work with a traditional Google Cloud. If you're working with NFTs, and is there anyone in the audience who's working with NFTs right now, or at least thinking about working with NFTs? Okay. Then maybe it's not as relevant here, but generally there is also a completely free solution for NFTs to work with, and we treat NFTs as a public good, so the knowledge which is created by the artist should be persistent, and it's free for all to use and store the content via NFT.storage. Maybe then we have an audience here which is actually hosting the websites or thinking about hosting a website. Who is doing something like that here? Okay, that's a bit better. So for those of you who are hosting the websites or thinking about hosting them, there is a Fleek hosting tool available to you, which is a wrapper for IPFS and Filecoin, which is designed to a fast, modern, censorship-proof hosting of the websites and web apps. And you can just connect your existing GitHub and publish your website to IPFS and Filecoin. Moreover, we have a Power Gate, which is a wrapper around everything. And if you want to have detailed control of IPFS and Filecoin, you can use that. And maybe for backend developers, we also run a project for peer-to-peer distributed databases. The peer-to-peer distributed databases uses IPFS as data storage, and IPFS databases PubSub solution to automatically sync databases between peers. The complexity of running a peer-to-peer database is that you always have to maintain the state across all the peers, and we have an additional library which handles PubSub communication all across peer-to-peer networks. It's also all open source and public, so feel free to see the GitHub repository and check how it works straight away for your project. And it's implemented on top of IPFS log, and it's currently actively being developed. It works both in browsers and Node.js, and it's compatible with JS IPFS and Go IPFS libraries. And frankly, one of the most amazing things that I see as a potential of Web3 is that we are also doing the effort to become truly sustainable and green, and not only just by buying carbon offsets, but we are actually doing it verifiably green, investing a lot into the infrastructure, which is accommodating the storage solutions, where we're building an open source tracker where we check the grid which every storage provider uses in order to verify how green is their particular storage. And you can see all the information in the public APIs to analyze and understand how green or efficiently your data is being stored, and you can choose the provider based on the requirements for the sustainability as well. And there are many, many more tools available to you in our OpenStack, so feel free to check the repositories, the libraries. I think it accounts for more than 1,000 right now, but there are 3 major, like IPFS, Filecoin, and libp2p, which you can follow, and then you can discover all kinds of projects in there. And speaking about all kinds of projects, I would also like to go through with you about the possibilities of the Web3. So there are literally a lot of opportunities for you to build. I have surfaced you only the application level tools, but there are also many, many opportunities for you to build user and client interfaces in Web3. You can also build smart contracts and compute layer, which essentially enables what's happening with the front end in the back end. And you can also develop consensus and hardware and networking solutions, which build this composable stack for the Web3 and for Web2 for any internet interaction of the future. There are many, many contexts and opportunities for you to build together. And if you're questioning who is, well, that all sounds fancy, but who is actually using IPFS and Filecoin right now? And all these projects are already using it right now. All the major blockchains and networks are using IPFS and Filecoin either as their storage layer, or they're using more protocols also for peer-to-peer communication. There are also projects like Polkadot, OpenSea, and many other blockchain layers and many other tools which you may use day to day, something like audio service, streaming services, which are also built on IPFS and Filecoin. One of the examples, or some of the examples which I personally enjoy out of those, and I want to surface it to you as well. For example, Internet Archive. It contains the most important humanity data, and it's all backed by IPFS Filecoin. So in case something goes down on their side, it's all archived on our side as well, and we always provide and store it to the public. The Starling Lab. The Starling Lab is a framework for data integrity, but what they actually do, they store the testimonials, video recordings of the Holocaust. And that's something which you never want to lose as a humanity. The history of the important events should be persistent over the web. And it's also backed by IPFS Filecoin to store indefinitely into the future and making sure that it's not changeable as well, or there is no alterations of it, so that we can always refer to something stable and secure through the IPFS and Filecoin network. There are also applications which you can use day to day, and maybe someone of you is using it already. There is a Huddle, which is a Web3 video meeting platform. There is Audios, which is maybe similar to SoundCloud or Apple Music, and that's an amazing tool where you can also not only see the content which you're listening to, but also see which samples which were used in order to create it, for those of you who are interested in music. There's also LivePeer, which is used for streaming of the videos. And for example, we're also collaborating with an open projects. We are storing right now the whole New York City open data about the city information on the Filecoin. And there are many, many more applications which we are bringing to you over the Web3 and over IPFS and Filecoin. So if you're thinking about joining, or even just interested about our ecosystem, I would say that our ecosystem is the strongest asset in the growing of Filecoin network and Web3. We are right now accounting for more than 4,000 of storage providers worldwide in all continents, in all places, in all different locations, and we're accounting for more than 18 exabytes of total storage capacity, which is right now approximately 1.6 of all total cloud network in the world, which is already amazing and which is already a huge scale, and there is definitely space to store your personal data or to store the data of your personal project. We also have an increasing demand from explosively growing ecosystem. We have in our ecosystem more than 300 startups building on top of IPFS and Filecoin, and we have more than 9,000 developers contributing to our protocols on a day-to-day basis. The beauty of building open source, and I believe we all are here around building something for the community, you can easily access it all on GitHub. All the code is available to you, and if you think that you can improve something or contribute to it, feel free to do the PRs. We're reviewing them daily, and it's just an open project we're all collaborating on top of. And moreover, IPFS and Filecoin is not then just a storage. We're also right now building the solutions for a compute layer, for programmability, and we're ensuring that our solutions are completely green foundation of the Web3. You can follow us more to see the details on Filecore and virtual machine, retrieval markets building, or just figuring out how to ensure that your project is collaborating in Web3 and building on the basis of contributing to the society instead of having it just locked and not developed by a small community. And to sum it up, in the end, Web3 is, in my opinion, is a complexity of or combination of three core things. First of all, it's decentralized web. It's based on a blockchain where you can have a sequential understanding of what's happening in the history, and it's a large amount of linked data. Whenever you have these all together, working to the best of each other, you have the Web3, and I personally believe that the best way to predict the future is to create it. Thank you for listening.
Fantastic. What an amazing talk. Hey, look, we found a face mic that works. But maybe, yeah, give it up. Actually, the production team, they're doing amazing work. Let's hear it for them as well. Like, you wouldn't have sound if it wasn't for them. Can you imagine? He'd be like screaming, the best way to predict, you know? So, like, production team, thank you. Amazing talk, by the way. How are you feeling? You feeling anxious, nervous, stressed, sweaty?
I'm excited.
Relaxed?
I'm excited for the questions from the
Absolutely,
audience. Absolutely,
yes, exactly. Let's give it up one more time for Konstantin. Really? You hesitated? Awesome. And we have time for 2 questions. Oh, wow. Okay, everybody's interested. You first, sir, there in the back. You may have to scream.
Yeah, so when do we have Git on top of IPFS?
That's a good question. Essentially, what do you mean by Git then? Which functions do you want from it? Well, so the version control is already inbuilt in the IPFS because CID references to exact content, so that whenever you create an alternated version of it, the CID will completely change. So all you need is to have the history of the CIDs, of the content or a file which you're working with, and you have this versioning. So if that's what you're looking for. Complexity of collaborating on a Git is tremendous, and we're also building decentralized solutions like GitHub in order for people to collaborate on it, on top of it. It's not built by Protocol specifically, it's built by the community, but these tools are already existing in the web, and I'm more than happy to share them with you once we come to the talk after the main session.
Awesome. Good. And there was another question. There we go.
Yeah, even though you're minimizing points of failures, what do you think is still one of the main points that could be trouble for this whole system?
Can you repeat his question and then answer it?
Yeah. So the question is, what are still the major challenges for the peer-to-peer networks in general? The beauty and the problem of peer-to-peer networks is that they were heavily underdeveloped in the last 20 years when we were super excited about centralized solutions. It's super convenient to work with it. You get all the resources, but at this point you also trade off your personal security, you create silos, bad things. I believe, or we see a major challenge is still the development of protocols in order for them to reach the convenience of traditional Web 2. So we have all this PubSub, maintaining of the databases in a distributed way, but that's all still being under construction, or the community is building right now and focusing on those challenges in order to make them as convenient to use as an existing Web 2 solution, so that the times are still the same, the collaboration is still the same, but it's all distributed in the backend, and you are not relying on a centralized authority to work with that. That, I think, is the main goal of the Web3 right now, and I think we're going step by step towards it until we actually reach it.
Awesome. There's the last question.
How do you avoid hash collisions?
That's a very good point.
Can you repeat the question just for the live stream?
How do we avoid hash collisions? I mean, first of all, 2 to the power of 256 is quite a large number in order to face the collision. But whenever we're actually still exploring the network if there were any hash collisions. To what we've seen right now, there wasn't, to my best knowledge. But I think that's a very good technical research question rather than question to the network itself. But whenever we face it, I think we'll address it as in the way it should be.
Awesome. Let's hear it one more time for Konstantin, everybody.
Thank you a lot.
So what's next? We're going to have lunch in just a minute. But before that, I get to show you this thing. It's called the Zara Fly. So as a thank you to me, I guess, the organizers asked me to talk a little bit about shit. What are you doing, man? The organizers asked me to talk a little bit about Zara, so that's where I work, and give you a bit of a demo. We build a database that... You're attacking me with the lights. We build a database. Okay, I see. He unplugged it. So we build a database because we believe databases are too hard currently for anyone wanting to build a product. And what I've been telling people is that we're a developer experience company, more so focused on making databases friendly, easy, trivial to provision and to scale and to migrate safely. Without any downtime, without any migration windows. So I'm happy to show you that today. And I won't be long. This is not like a 45-minute session, 5, 10 minutes maybe. Before I get into it, this ring is still missing. So if somebody lost this, come see me, okay? Otherwise, I'm keeping it, and I'll go to a pawn shop. And anyway. So Zara, what is the problem we're solving? This is a backend conference, so I'm happy to talk a little bit about databases here with diagrams, okay? So usually, you would have some type of app, maybe a front-end app that talks to some type of API layer. From your API layer, you would query, at some point, you're going to hit a database, a backend store, a data store. This is fairly common. App, so web front-end talks to API, talks to databases. Just getting here, we feel like, isn't as easy as we want it to be. How many of you have tried to provision a database on AWS? Wow, nobody in a backend conference. 3 people. Provision a database anywhere, serverless. Okay, yeah, there's more hands. So this takes time, usually. It takes a few minutes to spin up a database and bootstrap it, so to speak. On Zara, this is instant. I'll show you a demo in just a minute. But at some point, if your thing is successful and grows, you'll want to scale, vertically. You'll add, let's add some memory, let's add some disk space, and so on. You need to. Eventually, this gets too expensive, and you have the conversation, well, maybe we should scale horizontally, add multiple database replicas. This is complex to begin with. As your complexity grows, you're going to recognize, oh, our app's a bit slow because we're still reading from disk. What is faster than disk? Memory. So I've had this conversation at least 121 times, okay? Is it time for Redis? So you'll usually add some type of in-memory KV store to read from memory, which is faster. And so your app will then read from that. And if it's a cache miss, it'll go to the database the first time, populate Redis, it's all good, it's fast. As your data volume increases, your users are going to need a way to find stuff. GitHub.com, Instagram, TikTok. Go to any website with a reasonable amount of data volume. What do you have? Search. Search is important, so you'll need to then replicate your data into a search engine somehow. You'd probably use some type of queue, like Kafka or something. And so your database will have to logically replicate, or however replicate. Maybe you do statement-based. I don't know, it's your system. And so you'll need to, look how complex this is. And of course, your search engine is probably also going to be distributed. It's going to be something like Elasticsearch. And so this is non-trivial. To go from, I want to start, to I want to scale, to I want to, and now we haven't even talked about safely migrating. What if I want to change the schema? How can I do that? How can I run my migration? How can I test my migration? So all of these problems, we believe, if you're building any app, these are maybe not your problems to deal with. And maybe you're small and you can't hire a dedicated DBA team or whatever. Zara is your DBA team, okay? So what we do is we basically replace all of this, literally everything except your API, with our approach. So the dashed lines are now serverless, solved by Zara. And this is what I want to show you here. So this is our blog, zara.io/blog. There's posts here by some really handsome people. And I'm just joking. And so why am I showing you this blog? Well, we highlight things we do. So we just had this offsite. Hey, okay. This amazing food and so on. It was just a beautiful, this is our team. But why I'm showing you this blog is because this blog runs on Zara. We use our own database to build our own stuff. And I want to show you that journey on Zada. So if we switch tabs here, this is what Zada looks like. This is the org. So on the left-hand side, we have, similar to how in GitHub you can have organizations and repos, in Zada you have workspaces and databases. You can have any number of databases in your workspace. We have quite a few. And the blog powers the blog. So if I click on this blog thing, what we'll see is the inside of the blog database. It's not always this slow. This is conference Wi-Fi. I don't really need to defend it, but whatever. And if I go to posts here, these are our blog posts that you see here, okay? But you'll notice the order isn't the same. This starts with Jamstack, that starts with JSCon Budapest. So how do we sort? Well, we do this. We sort by date in descending order. And this is, by the way, it looks like a spreadsheet. It's actually a full-on database. It can scale, you can migrate it. It's also a branchable database. Like I can git branch my thing, change my schema, and merge it without downtime. We'll talk about that in a minute. So sorted results, looks good. I can click this button here to get the code snippet in a language I choose, JavaScript fetch. And I can run it anywhere I run JavaScript, including the browser dev tools. So if I run this here, I actually get back the records sorted and filtered exactly as I want. And this is how we build the blog front end. It's from filtering to a query, it's that straightforward. As well as provisioning databases is quite fast. I wanted to show you this just briefly. If I add a database called Worker, so lowercase, and I hit enter, that's instant. It's created, it's provisioned, I can query it. I can build tables, I can build a schema, I'm done. So that's the graphical way, but we know, as I said in the beginning, developer experience is the name of the game. And some people maybe want to write code all the time. They don't want to work with this spreadsheet. And so everything that I did with the web UI, you can do with code. So this is an SDK playground where I can literally use the Zada client to write code. So I can do Zada dot, and it's fully type-safe, db dot. And these in my editor are the same as my tables here. They're generated types on the fly. So I can do something like dot posts, dot get all, right? And I'll get all the posts. I can even filter here just before getting all and do a join across another table to authors. So I'll find posts where the author's name is me, and it's type safe. So if I mess up the column, it's like, wait, this is not going to work. So it's this. We want it to be this simple to query. But some people maybe don't. This is also probably too much. And maybe it's better to just stay in your project and not even leave your editor while working with your database at scale. So if you look at this little thing up here in Visual Studio Code, yeah, you can, everything I showed you can do like straight from Visual Studio Code. You can provision a database. You can scale a database. You can migrate it straight from here. So this is our Zada team. That's our blog database. Our database is branchable, so you can actually look at different branches here and mess with the schema and the dev branch if you want to. I can just like delete this table in the dev branch because I want to do it. Press enter to type the name to confirm. Boom, tables going, gone. Dev branch, who cares? On the main branch, I can explore whatever, it's a database. I know, like you're like anxious, we trust the system. So authors, I can view my data here as well, straight in VS Code. I can insert it. So that's a brief look. What I wanted to show you was Zada is predominantly about developer experience. From creating a database, to branching a database, to scaling a database becomes an afterthought comfortably, so that if you're building a music streaming service, a dating app, whatever, it's a solved problem. Think data and not databases. Does that make sense? Lastly, when you do your changes in a branch, you merge your branch to main. Usually, you've heard of like migration window or scheduled maintenance. Yeah, so historically, when you do a large-scale database migration, you have to tell users, hey, please, no one write anything for like 3 hours. It's Zada this instant. You merge it, nobody even notices, because we hide behind a REST API. So we receive the writes, and we can tell if a migration is in progress, and we coordinate the systems accordingly. So your users are like, okay, cool, never any downtime, wow. That's the demo. That's what I get to go to work and do every day, and then I get to speak about it at conferences, and if you're interested, are you really? Okay. We're private beta, so it's not yet public. We're going public in September-ish. But if you'd love access, I'd love to talk to you more and show you around. Also, we're hiring. So with that, hey, thanks so much. I appreciate the time. We're going to do lunch. This is where you applaud my demo. Now it's cheap. Now it's cheap. You lost. I had to ask for it. We're going to go do lunch. We'll meet back here in exactly 1 hour. Thanks. We'll meet back here in exactly 1 hour and 2 minutes. And feel free, the speakers are around, grab them, get some food, get some questions, get some knowledge, and if the ring belongs to you, come see me. All right? We'll meet back here in an hour.
with the results. That's still bearable. Not nice, but bearable. But then, is it really fine? Because looking at the code, you see that there's a single reject at the first thing that goes wrong. I'm killing off all the process, which is fine because I'm interested in having all good results. That's the behavior I want here. But when something goes wrong, I, 1, don't want to continue requesting more things. 2, canceling whatever is still ongoing, because there's no point letting resources go out. So in recent years, I have to say when I was writing my first lines of JavaScript, none of that was possible, but now the abort controller and abort signal have become standards, so there is a way you can do interruption. And yes, you have to do it pretty much inside the code. So this is becoming more complex and more complex and more complex, and the font is getting smaller and smaller and smaller. I hope the ones in the back can't read the code, so you're not gonna be scared by it. We are not close to what would be needed. As some of you said, there was 2 things going, well, problematic. Delays, timeouts, and, well, resilience.